Howdy, howdy. Testing, testing. Welcome, welcome. We are just starting, so let's let some people stream in. Oh, why is my mic so quiet? Weird. Why am I just left? So annoying. Well, I think that we're all set. All good to go. What is the hardest PhD? I don't think that that's a question that has an objective answer. Could you go into more detail as to why speeds cannot add to more than the speed of light? Well, look, so there are certain, how do I want to phrase this? The way that you figure out how speeds add is, or one way to figure out how speeds add is you have kind of three observers, or three people all at the same place that are moving at different speeds. So you have one person who's stationary, another person who's moving, and then a third person who's moving with respect to both of them. And you want to add the two people's velocities. So the velocity of A to B, so you want to add the velocity. So A is stationary, B is moving with respect to A, and C is moving with respect to B. If you want to know how fast C is moving with respect to A, the way that you do this is that you take and say you know how fast C is moving with respect to B. You take the velocity vector that corresponds to the motion of C with respect to B, and then you transform it, you do a Lorentz transformation, you get it back to the reference frame of A. And that's just not it's just not an addition. The Lorentz transformation is nonlinear. I mean, it's linear in some sense, but it's nonlinear in the velocity, and so the contribution is just not the two velocities added together. You have to do a Lorentz transformation, and then out pops the velocity addition formula in relativity. And the end result is that it doesn't end up being faster than the speed of light. How do we know that our laws of physics work across all space, time, and scale? I only have... So it's not that we know this for certain, but that we have good reason to think that it's true. One reason that you might think that it's true is that the kinds of things that we see in, say, the Andromeda galaxy are the same kinds of things that we see in much more distant galaxies. And those much more distant galaxies, we are seeing them as they were billions of years ago. And so, you know, if the physics were different, we would expect to see different kinds of things. We would expect to see different spectra for different stars and supernovas and things like this. Perhaps we would expect to see different mass distributions. And so the thing is we just don't see that. So it at least looks like galaxy, at the scale of galaxies, everything behaves the same way. Do you think there was another universe before this one? Well, I mean, it would all be part of the same universe if that were true, right? How do you reconcile the tension between physics and neuroscience/philosophy? I don't know if there is tension. How do you find nothing in the context of the universe? Has there always been something? I mean, I don't think that nothing is the kind of thing that can exist, so... Would you mind talking about theory that all the electrons in the universe are the same electron? Well, it's just not really a theory. It's not taken seriously by anybody anymore. This was like a cute idea that was just briefly discussed over a phone call in like the 1950s. Before we had like a solid theory of quantum field theory, or a solid understanding of quantum field theory. Now we understand the reason why all the electrons look the same is because there's one electron field, and all of the electrons are excitations of the electron field. Is physics a figment of our imagination? I don't think so. How do you feel about the negative time experiment that came out recently? I'm not familiar with it. Is there a good accessible science communication book that you can recommend that explains Hawking radiation? Probably A Brief History of Time. I would imagine that Hawking describes it pretty well. Why do you always talk about God as a physicist? Well, I don't always. I do, depending on what we're doing, maybe once or twice a week. Still doing flat earth debates? Well, I would, except the flat earthers, they don't show up anymore. Are you getting more and more into philosophy? How much does it actually interest you? If by getting more into it you mean reading it, no, I'm not. If by getting into it as in, do I think about it sometimes? Yeah. How much does it interest me? Depending on the topic, it does interest me quite a bit. What math class that is usually not required for a physics major should I take? Differential geometry. Have you ever felt nervous for upcoming semester because of hard material? If so, how did you manage? I did not ever feel that way. Unfortunately, I can't help you there. There's a lot of comments. I have to jump down to the bottom, but I will try to answer as many questions as I can. You reckon AI will completely take over theoretical math physics in the next 50 years? I can't predict the future. Sorry. When one describes the size of a black hole, where is the size measured to and from? It's just you could think of it as just like it's the distance across the black hole from the event horizon to the event horizon on the other side. There's no debate, it's measured flat in observable reality. Well, that's not true, but the flat earthers have seemed to stop coming to defend their worldview, so it seems like they've lost. What do you think of Lawrence Krauss' book, The Universe from Nothing? I haven't read it. How long does a white hole take to decay? If they exist, they decay almost instantly. How likely is it that dark matter is a subgroup of subatomic particles? It's possible. This is what a lot of people are working on. Can flat earthers debate you and ask a physicist live call-in? No. What's your opinion on the Cayley-Dixon construction? I'm not familiar with it. Is it possible that a universe exists inside of an outer verse? Well, then why would we distinguish between the two? What's your opinion on Newtonian physics combating the Big Bang Theory? If you're trying to use Newtonian physics to combat cosmology, you're doing something wrong. Do you think astronomy is worth pursuing? If you're interested in it, sure, yeah. Don't be too scientific. Very theoretically, where do you think a black hole leads? I'm not going to answer that because you're telling me not to do the thing that people are here to hear. That people are here to hear me do. How hard would I need to bounce a bouncy ball for it to reach the stratosphere? Really hard. Like that's a problem that you could do. It's a problem that you could solve, but I would need a pen and paper. How do we determine masses of celestial bodies like black holes, stars, etc. from far away? So there's a few different ways. If we have access to like things like if we can see the planets orbiting them, or if we can see like if it's like a binary star system or something like that, then we can use things like Kepler's laws to determine the mass of or the center of mass of the system anyway. The rate at which things orbit each other depends on the mass, of course. There are other features though, like for example, we can estimate masses of black holes by the sizes of the galaxies that they're found in. We can also estimate masses of black holes, supermassive black holes, of course, based off of gravitational lensing. We can do it based off of the energy produced by the black hole's accretion disk. There are a lot of different ways that we can estimate these. As far as stars are concerned, usually we have a chart. Basically, it's a Hertzsprung-Russell HR diagram, which basically says like colors correlate with certain masses, and we can then look at the stars and see what kind of colors they are, and we can figure out how heavy they are that way, that kind of thing. I'm surprised you stopped reading philosophy. Are you satisfied you can handle anything theists throw? I've never read any philosophy, except like the 1 or 2 classes I took in undergrad. That was 10 years ago. From Tim for Pele with the $5. Since black holes aren't objects, would a Kerr black hole's rotation be considered intrinsic angular momentum a la spin in QFT? No. So the rotation here is actually the angular. It's somehow related to the angular momentum of space-time. It's not intrinsic angular momentum. So there is in some sense something with angular momentum. It's just the space-time itself that has angular momentum, not like and the space-time itself is in some sense spinning. That's a good question. Does he only read TikTok? No, it's just TikTok questions are the ones that are coming in right now. We just don't have a lot of questions otherwise. Your answer to the Fermi paradox: the universe is big. Very, very big. Remember in one of your videos you mentioned virtual particles aren't actually real, then what explains the Casimir effect? You can explain the Casimir effect using a relativistic London force. It's just a version of the van der Waals force. You don't need virtual particles to explain that. Is intuition justification? Perhaps for some things. What the nature of light? How does the nature of light determine the shape of the light on the event horizon? I don't understand the question. Determine the shape of the light on the event horizon? I don't know what that means. Why is it that radio waves can pass through walls, red light can't? It just has to do with the kinds of electromagnetic radiation, or the kinds of electromagnetic waves that the material that composes the walls can interact with. So depending on the kinds of atomic structures you have, or molecular structures you have, either the electrons, either around the atoms or around the molecules or kind of in the crystal lattice, can absorb radiation of that frequency, or it can't. If it can't absorb it, then it'll pass through, right? The electromagnetic wave will just pass through because none of it will get absorbed by the electrons. For metals, the electrons can absorb basically, the electrons are very, very free, so they can absorb tons of different kinds of energy. But for non-metals, like, you know, a wall, the electrons are pretty rigidly bound, and so they can only absorb certain kinds of radiation. And so it's just the case that, like, the kinds of radiation that they can absorb are low frequency, or are high frequency and not low frequency. What observational signature would definitively distinguish cosmic inflation from alternative paradigms like the ekpyrotic or bouncing universe models? So these are going to be things like gravitational wave signatures in the CMB. These are going to be things like gravitational wave backgrounds at the cosmic scale, not found in the CMB. Those are, I guess you could talk about like domain walls. If these could be found, then we would expect different signatures for different paradigms. But usually it's gravitational wave signatures. Could universal constants be different outside the visible universe? I suppose they could be, but we would need some sort of explanatory mechanism for how that works, and why we would think that that's the case. If physics doesn't point to the Big Bang as the beginning, what do physicists believe came before it? There's no consensus on it. It just depends on the person. What really is space? A piece of space-time. In physics point of view, does the world expand forever, or does it stop at one point? Well, it seems like the universe has been expanding for 13.5 billion or 13.8 billion years, and it's looking like it will continue to expand. Now the question is will it stop? Will it slow down? Will it speed up? These things are not yet. These things are not on as solid ground as they used to be. Is this the same Kerr as in the nonlinear optics? I actually don't know. I wouldn't think so, but maybe. What caused the universe to pull away from local thermal equilibrium? If you're talking about in the very early universe, likely, and this is what one physicist contends, named David Deutsch, and I incline to agree, is that while the gas or the plasma was in thermodynamic equilibrium, the plasma was not in thermodynamic equilibrium with the space-time itself, i.e. the space-time itself had some very large expansion rate, and those are not in equilibrium. So the drive to equilibrate involves also equilibrating with the expansion rate, and so you end up with evolution that drives away from what looks like thermodynamic equilibrium if you just only look at a certain time, at a single time slice. Is 3 + 1 space-time equivalent to 4D space with a different interpretation? Yeah. Sorry, I have to jump down to the bottom because you guys are asking a lot of excellent questions, by the way. Is exotic matter possible to invent or just theory? We have no evidence that it exists. You explain how the universe works, but who explains why it exists? That's begging the question that there is such a who. How do you prove the existence of dark matter? Well, so in science we don't really work with the business of proofs. We work with the business of evidence. But what we can say is that there's a lot of evidence for dark matter. So dark matter was first proposed in the 30s, I guess, and in the 70s we saw that galaxies seem to be rotating faster than the observable mass should allow for. If they were rotating too fast and they don't have enough gravity, then they would fly apart. But they were rotating fast and they weren't flying apart, which indicates that they have more mass than we thought. And then we started looking for gravitational lensing effects, and we found that in places where there's not enough mass for there to be not enough visible mass for there to be substantial gravitational lensing, we're seeing tons of gravitational lensing. So there's something that's causing light to bend that's not mass, that's not the mass that we can see. So this is, again, more evidence for dark matter. Then there's evidence for dark matter in the cosmic microwave background radiation, namely that we can basically predict the total amount of matter in the universe based off of the CMB. And we find that the total amount of matter in the universe is more than what we can see, more than the amount of matter that's visible. So again, that's evidence for dark matter. So there's just a lot of different pieces of evidence that kind of come together. What's de Sitter space? De Sitter space is a maximally symmetric solution to the Einstein field equations, to the vacuum Einstein field equations, I should say. you should think of it as kind of like a universe that's forever expanding. It's kind of like what our universe is like if our universe is going to expand forever. Is there any unexplainable phenomenon that physics is currently trying to solve? Yep, dark matter, dark energy are two big ones. Why do only very large masses have orbits? Surely anything really small can do it. So depending on the bigger the mass, the more gravitational effect it has on its surroundings. And so if the gravitational effect on the surroundings is sufficiently small, then there might be other effects that dominate it and ruin any potential orbit. But it's true, if you took like a baseball or like a basketball or a bowling ball or something, and you just put it out in deep space where there's nothing around it for, you know, millions of light years, then yeah, you could see orbits happen for, like, you know, a baseball could orbit a bowling ball or something. Could bodies of negative mass exist in practice or only in theory? Well, so we don't even have really any theories that do this. So what's the best explanation for why the mass of matter affects space-time, giving us gravity? There's not really an explanation for why this happens. There's just a description of how it happens. There's a formula that relates the curvature of space-time to the mass of a thing. But physics, again, physics doesn't really work in the questions of whys. Whys kind of imply intention, kind of imply reasons, but reasons imply a reason haver. Is space-time fundamental, or could it be an emergent description or something else? So I made a video recently about how I think that it's, or about how it could be emergent, and I actually kind of tend to lean that way. I think that it's very possible and in fact quite plausible that space-time is emergent, but we don't really have data one way or the other. Why do you think there's something rather than nothing? Because I don't think that nothing can exist. Why does F equals ma and not mv? Well, so mv is in some sense momentum. Forces just describe how momentum changes. And so forces are going to tell you the rate of change of momentum, or forces are going to affect the rate of change of momentum. And so the rate of change of momentum is the mass times the acceleration. Does quantum physics prove that something can be made from nothing? No, but one of the kind of conceits of quantum mechanics and quantum field theory more generally is that there are things which are fundamental, which aren't made of anything. They're the smallest things. Now, whether that's true or not is a different story, but this is one of the kind of foundational assumptions of QFT. Can you explain to me, like I'm a monkey, what can we learn from the double slit experiment? We can learn that what we think of as particles are actually waves. That's what we learn. And that entanglement is a thing, that too. How does the recent discovery of ancient well-formed galaxies affect our believed age of the universe? It doesn't affect our believed age of the universe. What it does affect is it affects our understanding of galaxy evolution. So prior to 5 years ago, we basically didn't, we had no data that gave us any information about how early universe galaxies formed. So we just looked at late universe galaxy formation, and we just assumed that that's the same kind of thing that happens in the early universe. But that was wrong. If gravity is not a force, why does it need to be unified with the other forces for quantum physics? Gravity is a force. People who say otherwise just don't know what a force is. Do the Bell inequalities prove Einstein wrong? Perhaps. But they happened after Einstein died anyway. Is dark matter actually dark, or is it just named after it being invisible? Yeah, it's just invisible. Is the pressure in a pressurized container equal, or is it more in the center or the edges? I mean, if it's in thermodynamic equilibrium, then it better be equal. By the way, there are a lot of questions. If you want your question to be guaranteed to be answered, head on over to YouTube and send a super chat. I do prioritize those. Please, how can you link causal set theory to GR? It's hard. Would you debate Jesus and whatnot on the existence of Jesus? Well, we probably would agree on the existence of Jesus. What the question is whether or not we agree that, like, the God of the Bible is real, and then we would probably disagree. And so yeah, I would, absolutely. Is there a possibility that the Big Bang was the death of a supermassive black hole? Not really, because supermassive black holes don't die, and they don't really die while they're supermassive. In order for a black hole at all to die, it has to get smaller first, and that's very, very slow. Only once it's very, very tiny does it, like, kind of explode, but then it's very, very tiny. From Roundhound with the $20 thank you so much, bud. If increased speed slows time and light speed apparently sees no time, would slowing velocity to no motion at all make time go equally as fast, and what light speed slows as fast and what light speed slows time? Ipso facto velocity creates time, kinda. No, velocity is motion through space-time. And so depending on how you're moving through space-time, you might travel through space or through time at different rates. That's the simple way to put it. It isn't the case that light speeds no time. This is like a kind of one of these pop sci misconceptions. Light has a past, light has a future, light has a present. These are all well defined. It's just, in fact, you can even define durations. It's just you can only define them up to multiplicative constants. But it is true that if somehow you are at rest with respect to, say, the cosmic microwave background radiation, then everybody else would have, in some sense, you are moving through time, moving through cosmic time the fastest you possibly can. It's a good question, though. Since Navier-Stokes is unsolved, how do we figure out what assumptions to make it work in practice? Experiments, right? Like, Navier-Stokes is a good approximation to the way the world actually works. It might even be the way the world actually works. So the point is that you can run experiments. From Missy Debbie sending one Dr. Blitz debunks gift membership. Thank you so much. This is a good time for me to shill. So it's worth noting that if you have a $5 a month membership on YouTube or TikTok or Twitch or wherever, I do these live streams twice a week for an hour and a half after the large public one, and where the only people who can ask or send text questions are the people who are part of the $5 a month membership thing. Now anybody can watch, so the education's not gate kept, but the only people who can ask are the people who are going to have these memberships. So it's a good way to make sure that your questions get answered as well. Also, there are other perks like a private Discord channel. You get access to emojis and you get access to my debate notes. So, you know, it's worth considering if you have $5 a month to throw around, if you want to support what I'm doing. If not, don't worry about it. Feel free to ask your questions here. I'm happy to answer them. From Hashi with the $2, can you elaborate on why gravity actually is a force? Yeah, so gravity does two things that make it a force. First, it allows for momentum transfer. Momentum transfer is how we define a force. A force is a thing that changes momentum, and gravity can change momentum. Secondly, gravity is described by a curvature, but all of the quantum forces are described by curvatures. So if merely being a curvature is enough to make it not a force, then none of the quantum forces are a force. Best evidence to disprove the flat Earth. Yeah, the best evidence in my view is like sunsets or sunrises. From the frame of reference of the beam of light, how long would it take that beam of light to travel 1 light year? There is no frame of reference for a beam of light. What is dark matter? I suspect that dark matter is some kind of particle, but we don't know. It's just a matter, it's something that has mass, and we can't see it. What recent finding are you the most interested in or think is the most groundbreaking? Recent? There hasn't really been anything that's like been on my headline news or been a headline for me that I'm like particularly fascinated by. Perhaps in the last few years, though, there was this there's a tentative discovery that the universe is that dark energy is not a cosmological constant, but this is still tentative. Why is it hard to link causal set theory to GR? Because causal set theory is not even like a fully fleshed out idea. Not even clear how to express all of the curvature invariants in terms of causal sets. From Git Stanfield with the $5, has the consensus in cosmology already explained the jets that shoot out from massive black holes? Why do they shoot out? No, this is an active area of research. There are some ideas, but these ideas are kind of approximations. It's just a really complicated system, right? You have high curvature regions of spacetime around black holes. You have extremely high temperatures, so you're working with like plasma physics, and you have strong magnetic fields. And you have, so you have fluids, which is, you have charged fluids in strong magnetic fields in highly curved spacetimes. And this is just a really complicated system. So there are ideas as to how these, they're kind of simplified models, like the Blanford-Znayak process is a simplified model for how jets form from black holes. But like, this is, in fact, if I remember correctly, Skylar from Skylar or Science with Skylar, she's an excellent science communicator and she just finished her PhD. Her PhD is on black hole jets from supermassive black holes. So like, this is an active area of research. And from Melodic Lyrics with the $2, thoughts on gravity as emergent from entropy? I don't buy it. I don't think that it does enough. I don't think that we can get enough from just entropy. The real best evidence against flat Earth? Yeah, that's true. True, it is neutrinos. It's always neutrinos. What's the best proof of the Oort cloud? Well, one of the best pieces of evidence for the Oort cloud is the existence of comets. Comets with long periods. That's a pretty good piece of evidence. Is energy bound within the universe, or can it flow through a multiverse as like a concept? Energy is not a thing. It's not like a substance. So maybe that helps you reframe your question. Did you ever meet Ed Witten? I shook his hand once. But that's it. Is time a physical thing? I know black holes and such can bend time and alter its speed. Is it? Yeah, I mean, it's a physical thing as far as space is a physical thing. What has CERN taught us? Well, we found in 2012, we found the Higgs boson, which was like, you know, the goal of building the thing. So if light does not experience time, is it safe to assume to the perspective of light, time does not exist? No. Light, it's incorrect to say that light doesn't experience time. There is no valid reference frame for light, so there's no question. There's no answer to the question, what does light experience? What is a Lie group? It is a special kind of compact continuous group. I guess, in fact, is that just the definition of a Lie group? Is it just a compact continuous group? Oh, it's also a differentiable manifold. That too. And I guess it doesn't have to be compact. Yeah, I guess you can have non-compact Lie groups. It's just the ones that we usually work with in physics are compact. Opinion on the little red dots found by JBST being claimed to be black hole stars. It's neat. I'm looking forward to seeing more research on it. Why are you on TikTok? Are you trying to educate, or are you trying to make money? Why can't it be both? I mean, like, look, when college professors teach, they're doing both. When school teachers teach, they are trying to educate and trying to make money, because people need money in order to live in this world. Energy is if something is unlevel. What? Is there anything that's impossible to happen tomorrow, like p equals 0, not slightly bigger but exactly 0? It depends on what modal scope. I hate that I said that. I mean, like, yeah, like the kinds of things that can't happen would be things that you know, are not allowable by quantum mechanics. So, for example, you know, the universe couldn't spontaneous or yes. So there are transitions that are forbidden. Meaning that the probability of them is 0. For example, in an isolated system, it's impossible for a spin-up electron to suddenly transition to be a spin-down electron if it's isolated. But, you know, the question is, how do you get it perfectly isolated, right? From Derpwolf with the $10, thank you so much, Derpwolf. I accept that physics says we can't travel faster than the speed of light, but I also believe it will at some point become possible. Why should I not believe this? Well, look, if you have a general trust for physics, then you should just believe what the physics says. Now, there's kind of two different things happening here. In principle, you could have a warp drive, and a warp drive doesn't make you travel faster than light locally, so you're still respecting relativity, but you're traveling between point A and point B faster than light could travel between point A and point B if it's not also within the warp drive or within the warp bubble. So, like, you know, but if you want to talk about traveling faster than light locally, like if you want to talk about like outracing light, like a beam of light that's next to you, you should not believe that you should believe that that's not possible, if only because we have so much evidence that says it's not possible. Does the GZK limit depend on the age of the universe? No, not really. It just depends on the temperature of the CMB. How does an electron decide which path to take in a double slit experiment? It doesn't. It takes all of the paths. Have you seen Patini's paper for the 3-2 spacetime dynamic hypothesis trying to explain quantum entanglement? Nope, haven't seen it. I saw your thinking about the Big Bang right there. Say your thoughts. What? How does string theory solve the contradictions between relativity and quantum mechanics? It's not that it solves the contradictions, and it's not even really that there are contradictions. It's that, like, it's just that we don't know how to merge them. And string theory just gives us a way to merge them. I'm struggling so much with the answer, light doesn't have a reference frame, but ChatGPT agrees with your answer. I guess I need a lot more knowledge to understand this. I'm glad that you fact-checked me with ChatGPT, I guess. Is there evidence of time dilation being possible at speeds close to the speed of light? Yeah, absolutely. In fact, this was one of the most damning pieces of evidence to show that special relativity is real. I think this was back in the 50s or 60s. There was an experiment where they basically measured the decay rate of muons. Muons are a fundamental particle that eventually decay into electrons and some other stuff. But the important point is that they have a lifetime of about 2.2 microseconds when they're slow and, you know, not moving very much. But when they measured the decay rate of very high energy muons moving very, very quickly, they found that the decay rate was several times longer, which is time dilation, right? Are you more physics or math? I'm basically straddling the barrier or straddling the boundary. What do you think about the well dataset? I have no idea what that is. If QFT can accurately describe the other fundamental forces to such a high degree, then why does it not stand to reason that gravity is just everything else? Hold on, I need to see that. What do you mean it's just everything else. I mean, like, gravity is everything else. Is there anything in physics that genuinely makes you question whether reality is real? No. What is your favorite food in a tortilla? Barbacoa of some kind. From C-Bar with the $10. Very much appreciate that. Thank you. I just saw your string theory post saying the research methods helped solve other problems. Does string theory have its own maths that is now being used by other fields? Yes. Yes, it absolutely does. I mean, it's not its own math, but like this is like the kind of stuff that was developed for string theory or in relation to string theory, and now it's being seen elsewhere. Do you have any advice for students who want to become future theoretical physicists, astrophysicists? Yes, if you love it, do it, but recognize that getting a job in physics, like doing physics research, especially as a theoretical physicist, the odds are very low. Is it possible to create a sort of clock using the periodicity of gravitational waves? If so, will it be affected by the same dilation effects as other clocks? Yes. Yes, gravitational waves, if gravitational waves are accurately described by general relativity, which they are, then time dilation affects everything, not just light, not just atoms, not just anything. It would affect everything. The thing is if you want to make I guess you could make a clock with gravitational waves, I guess. When did you realize string theory is the best, and what made you realize that? I realized that string theory was the best the same time when you stopped beating your wife. No, I'm sure that you love your wife. In fact, I know that you love your wife, but you know, don't ask loaded questions. How's recovery from surgery? I'm good. What is the lifespan of a photon? Photons don't decay. They're massless. They can't really decay. How does light accelerate? It doesn't. Light just exists at that speed. Are you also a cosmologist? Depends on who you ask. I've written at least one cosmology paper with some colleagues. I'm working on at least one. No, I guess I've written a few. So yeah, I mean, like I at least dabble. Dr. Blitz, can you supply some intuition for torque? No, I can't, because it turns out that torque is really, really unintuitive. There's a paper I actually want to show you. There's a really excellent paper that was that actually derives was it Matt Parker or was it Veritasium? Maybe Veritasium. So Veritasium sorry, I just want to make sure I find this. There's a really good paper, and I can't find it for the life of me, but basically it actually like derives like the torque equation from first principles using just F equals ma, and it's Veritasium didn't write it, but he brought it to my attention. He brought this paper to my attention, and I wish I could find it. It was a really good paper, and I read it. It was like a year or two ago. Well, it may have been Matt Parker. Okay, well, I can't find it. I'll have to find it later. Maybe I'll make a video on it or something, just to bring attention to it. But it turns out that it's like less straightforward than you'd think. What does time mean to you as a fundamental property of the universe rather than a human clock? It is part of the stage that we all exist in. I trust that physics is right, but I guess I don't believe anything is written in stone. If we could build a theoretical craft for FTL travel, then I think it would just work. Well, okay. Is materialism true in general according to science, especially considering physics and math, or is it the other way around? It just depends on how you define materialism. What are the chances of us currently existing in a black hole? I don't buy it, but you know, these are not the kinds of things that you can put chances to, right? You self-teach physics at home? You can, but it's going to be very hard. Can I become a physicist if I dropped out of high school? I guess in principle, but you have a lot of catching up to do. String theory is true, then that would mean that an electron, for example, could turn into a photon. Not necessarily, not without some sort of decay mechanism, and you know, you'd have to look at the specific models of string theory to see if that's an allowed decay, and I suspect it wouldn't be. Remember when Veritasium took money from AI taxis and pretended it wasn't advertising until an offhand comment halfway through, and took Toilet Wipes money to do a fake experiment proving they... Yeah, no, like, Veritasium, you know, I don't really pay attention a lot to Veritasium, but he did have... I think it was Veritasium that had a video about Torque. It was either Veritasium or Stand Up Maths. I don't remember which one. Oh, it's called Physical Intuition for Rotational Motion. Let me see if I can pull it up. Is it this one? No, it's not this one. It's close, but not quite. Does the speed of light or change? Does the speed of light change in the medium? Sort of. The effective speed of light does. Does all time exist simultaneously, past and present? Well, and future, but simultaneously isn't the right word here, because simultaneously is kind of a time word. You might want to say that all moments of time exist equally. That would be a fair characterization under the B theory of time, which is the one that's, at least in my view, most well-grounded physically. What are axioms? Axioms are kind of, they're propositions or facts, or the propositions or statements that are assumed to be true, and then results are derived from that assumption, from those assumptions. Would you ever get a dog? Yeah, in principle. What's the difference between physics and mathematical physics? Mathematical physicists do more mathematics. Okay, the physical origin of torque and of the rotational second law. Oh, this sounds right. Yeah, okay, this is right. This is the one that I read a while ago. Let me just show you guys this, because it's fascinating that this is a thing that, you know, exists. So this is the paper that I'm talking about. This is a paper that was, you know, it's like a serious paper. We derive the rotational form of Newton's second law from the translational form by performing a force analysis of a simple body consisting of two discrete masses. Curiously, a truly rigid body model leads to an incorrect statement of the rotational second law. The failure of this model is traced to its violation of the strong form of Newton's third law. This leads us to consider a slightly modified non-rigid model that respects the third law, produces the correct rotational second law, and makes explicit the importance of the product of the tangential force with the radial distance to torque. So this is saying that, like, if you tried to derive this just using like a true rigid body, you would get the wrong answer. Right, like this is it's very weird. Like this is not the kind of thing that you learn in a physics class, and like this is correct, you know, but it is just very weird that torque is that, or that the rotational second law is. It seems so intuitive, but it's just not. It's very hard to derive. Anyway, oh, I should keep that open, and I should, you know, make a video on it or something. Do you have a microphone just for your keyboard? No, it's just a loud keyboard, and I like it that way. What do you think of theoretical physicists suggesting dark matter could have its own force? Yeah, it's plausible. Seriously, a photon, a wave, a particle, or an energy field that we can measure as a wave or particle? It is a wave that sometimes behaves like a particle. Randall Knight wrote a response to this. Randall Knight response to... Really? Like in a good way? Proving that rigid models remain... Oh, interesting. I'd have to go look at that. Oh, this might be... There might be some drama. I'll have to read these and actually, like, compare them. Wait a minute. Where's the... Yeah, here it is. Interesting. Interesting. It may not be as settled as I think it is. I'll have to go and I'll actually have to like read through it again. But yeah, I mean, it's definitely not. It's definitely seemingly not trivial. Because I guess the responses are published in like actual physics journals. This is sufficiently non-trivial that, you know, these are like actually published. Fascinating. How do you feel about the TEA argument for the creation of the universe? It's nonsense. And like it assumes certain properties of the universe that are just not the case. What's the most recent thing that you've learned that blew your mind? That there's a fight over this. That there's a fight over the origins of torque. Let me drink some water. We have from Casey. We have $6.66 from Casey on Venmo. Kind of for a document camera so you can do physics problems during stream. Shout out to Mel, but also for devastating your mom joke yesterday. Credit where credit is due and all. Yeah, your mom joke was devastating, but also a document camera would be a good idea. It's probably not in the cards until I move. I plan on moving in, you know, eventually in the next few months or next several months, because then I'll have more space to set up a kind of like have these things set up. Currently, my setup is fairly limited in scope, but a document camera is a good idea, actually. I appreciate that, Casey. All right, let's keep reading. Is the universe infinite? It might be. We don't really know. Kind of an open question. Are tachyons real and how do they behave? No, tachyons are not real. Not as particles, no. Can you bend space-time the other way so you can travel to the past? No. Seemingly no. You would need the wrong kind of matter, or you need a kind of matter that seemingly doesn't exist. Can the expansion of the universe be thought of as a decrease in overall density? Yeah. How does the speed of quantum entanglement travel faster than the speed of light? Well, quantum entanglement isn't really a thing with speed. Not like a thing moving. Is it against some rule to not wear glasses and have a normal haircut as a scientist? Yes, it is against the rules. When particles dissipate, where do they dissipate to? I don't know what you mean by dissipate. So some particles are just not conserved. So photon number is not conserved. Photons can be absorbed, they can be emitted, they just disappear. They just cease to exist. Other particles, if they cease to exist, they cease to exist because they decay into something else. So for example, a muon might decay into a muon neutrino, an electron antineutrino, and an electron, for example. How does the Riemann zeta function relate to quantum mechanics? It doesn't really, except I think it shows up in some derivations of some amplitudes in string theory. Ugh. Sorry. Did the collider actually turn lead into gold? Yeah, just not very much of it. How does the speed of quantum entanglement... Oh, okay, I already answered that. I should jump down to the bottom. Why do you think there's far less antimatter? I don't know. This is not something that I have an opinion on because I haven't spent time thinking about the problem. This is an open problem in physics, though. Like the question of why there's more matter than antimatter is not something that there's any sort of consensus on. How does the geometry of the extra dimensions create electric charge in string theory? You'd have to ask a string theorist. This is not something that I know off the top of my head. I'd have to go refamiliarize myself. Good morning, host and friends. Good morning, Dr. Joe. Always good to see you. Do you believe in timeless space? I think it's at least possible. Believe in it is a strong word. Jumping down to the bottom. What's your take on loop quantum gravity? I think it's cute. I'm not sold, but I think it's cute. Are the CERN physicists now alchemists? Yes. What made you pick physics? I saw a picture or a rendering of a black hole when I was a kid, and I'm like, oh, that's the coolest thing. And that was it. That was it. Do you think our models representing space-time as discrete is strictly a result of measurement? Not necessarily. It could be that space-time is actually genuinely discrete. What's your field of study primarily? Generally, if it has to do with gravity, that's something I'm interested in. How many tunnels are under your city, and where's the chicken when it's on the grid just at the houses with the red dot? What are you talking about? Is Warp Drive project possible for 1 to 20 years after 2026? No, I'm not even familiar with the Warp Drive project. So what does an alpha or beta particle dissipate into? So an alpha particle is a helium nucleus, so it doesn't really dissipate into anything. It's just a helium nucleus that just sticks around. A beta particle is an electron, so it just gets captured by some atoms. Eventually. Can you explain what symmetry naturally derives electromagnetism? Yeah, it's called a U1 principal gauge bundle. Or a U1 Lie group, or a U1 gauge algebra. or U1 Lie algebra. So this is the symmetry of a circle, basically. And what happens is that if you slap a circle down at every point in space-time, and you allow your phase on that circle to be different from place to place, and you also allow the way that you connect one phase to the next phase to be, you know, some arbitrary way, you automatically get electromagnetism out, which is really quite interesting, as long as you also include special relativity. Are you open to the idea that everything in the universe was designed? I mean, I'm open to it insofar as like I'm willing to hear evidence for it. Is space-time a fundamental entity or a mathematical construct emerging from quantum interactions? Hard to say. Could our lack of knowledge about light's reference frame be somehow related to our lack of understanding of black hole singularity due to the historical development of GR from SR? It's not that we lack knowledge about light's reference frame. Light is, like, in relativity, light is the, you know, the world line that light traces out is defined to not have a reference frame. It's not that, like, we don't know about it, it's just that it doesn't have one. We define reference frames in a certain way, and light doesn't have one. But that assumes it's possible to have infinite past moments. No, that's the question that's the assumption I'm questioning. It doesn't assume that, no, and having infinite past moments seems like it's possible. Could you explain what a quantum field is? Not simply. First I need to explain what a field is. A field is essentially an assignment to every point in space-time of a number, or perhaps a vector, or perhaps some quantity, right? It's an assignment of something, some quantitative thing, to every point in space-time. And so you plug in x, y, z, and t, and you get out something. You get out a number, or a vector, or a tensor, or, you know, a pseudoscalar, or whatever it might be. You get something. Now, a quantum field is like that, in that you assign something to every point in space-time, except here you're assigning quantum operators. Or differential operators, rather. These differential operators, they act on... or I should just say operators. They're not necessarily differential operators, but they're just operators. So you assign operators to every point in space-time, and those are, so they're basically they're basically kind of functions that take inputs and give outputs. And so, like, those quantum operators can act on, say, the vacuum state and output a particle state. And then there's, of course, it goes way deeper than that, but that's the rough idea of what a quantum field is. Can you please help me understand Lorentzian barriers? I'm not sure what that is. What's your field? Oh, I already answered that. Oh, I'm way behind. Thank you guys for all of the good questions, by the way. I do appreciate it. It's very, very appreciated. My teacher said objects need a force to keep moving. Your teacher is... Who's your teacher? Like Aristotle? Can you explain consciousness in the quantum realm? I'm not sure if quantum mechanics plays a role in consciousness. Can you explain how the speed of dark is faster than the speed of light? Dark isn't a thing that moves. Are you currently researching anything or working on any projects? Yeah, I'm working on too many projects, actually. Like I have like, it feels like I have a meeting like every single day working on about some other project. How do we have measurements of stars older than the Big Bang? Well, we don't. Early approximations of the Methuselah star put its age at older than 13.8 billion years, but it's been revised downwards. Did Noether's first theorem also disprove energy conservation in a local spacetime? No, it's this about the first theorem. If I might be getting the order wrong, but if I remember correctly, the first theorem is about globally conserved quantities. What's the Sphaleron process? It's a non-perturbative process that can potentially break baryon conservation number. I do have a video on the Sphaleron process, though, if you want to check that out. At least it's on TikTok. I don't know if it's on YouTube. Can you explain what applications does ADS-CFT have in condensed matter? My understanding, and again, this is just my understanding, I don't do condensed matter, but my understanding is that the ADS-CFT correspondence lets you talk about strong, or what are they called? Strongly coupled systems in the CFT side with weakly coupled gravitation, or with weak or low curvature gravitation, which is really handy because we understand low curvature gravitation really well. And so if that can tell us about strongly coupled CFT systems, and condensed matter systems can be strongly coupled, then we can perhaps learn something from that. Could a massless scalar field exist in the standard model? At tree level, sure. There might be perturbative problems, or there might be renormalization problems. I guess it also would depend on like if it has like a potential, if it has like a non-zero potential, like what other kinds of terms show up. Our differential and the differential operators are tiny people going, let's take the partial derivative. Yeah, there you go. You don't argue with flirfs anymore? I would love to, but they stopped showing up. Do you think we will ever find evidence of white holes in the universe? I suspect not. What are closed time-like curves? So these are paths through space-time which loop back on themselves. And they're time-like, meaning that an object like you or me could travel along them. What's your take on the setup of the universe, physical chance or intentional design? I don't think that those are the only two options. Time symmetry is broken globally. Thank you, Nether, for blessing us with this fact. Indeed, thank you, Nether, for blessing us with this fact. Did you hear about the scientists who turned lead atoms into gold atoms? Yeah, in fact, this isn't news. This was, like, I saw this in the news like over a year ago. I don't know why it's making the rounds now. How do photons know that we're watching? They don't. What is genuinely conserved? It seems like there are no conserved quantities. Angular momentum. Angular momentum is genuinely conserved, because at least it still looks like our universe is homogeneous and isotropic. If a black hole's gravitational pull scales with its size mass, would they not grow exponentially? Not necessarily. Like, there's only so much stuff that can fall in, and you know, it's not like the gravitational pull gets like outpaces the amount of stuff that they're eating, right? Eating in big air quotes. If gravity is the curvature of space-time, why do objects still accelerate when no force is acting on them? Well, gravity is a force. It's a force. Curvatures can be forces. And the point is that, the point is that when gravity is, when like an object is in a circular orbit, for example, we would say that it's accelerating from like a Newtonian point of view, but its for acceleration is actually zero. Its proper acceleration is zero. Can you explain infinite blue shifting? Infinite blue shifting is a thing that we hope doesn't happen. Infinite blue shifting is this idea that, you know, as say light falls into a black hole, from an outside observer's perspective, that light gains energy as it's falling, and so its frequency increases, and in fact it increases without bound. From an inside observer's perspective, I'm sorry, from like inside the black hole, the light, the frequency of the light increases. And that would be bad, because then you end up with infinite energy, which probably don't want that. Why do people think that black holes lead to other universes? Because Lee Smolin said they might, and they're also mysterious. Stars are often described as low entropy gravitational objects, yet once an event horizon forms, we assign an enormous entropy to the black hole. What is the physical reason for that change? Well, I mean, ultimately we don't know, but the idea is that black holes are basically the maximal scramblers. So like if a star is low entropy, perhaps, if you take all of that matter and you scramble it maximally, then you end up with maximal entropy. And that's roughly the idea. Would an infinite blue shifting violate energy conservation? Yes. Yes, it would. Do you think Bell non-local correlations could be local in a higher dimensional causal structure? Probably not. Probably not. What is the theory of seeing two suns? I don't think that this is a thing that people actually see. Unless they're like hallucinating, of course, which, you know, people do sometimes. Have you cried during Interstellar? No. Can you explain how scientists have proven relativity using solar eclipse? Okay, so you're talking about the measurement by Arthur Eddington in 1919. So you're talking about general relativity in particular. So what happened is in 1919 is that there's this prediction, right, that gravity bends light. This in fact would happen under Newtonian mechanics just as well as it would happen under Newtonian gravity, just as much as it would happen, or qualitatively in the same way that it would happen under Einstein's gravity. However, Einstein's theory of general relativity makes a different numerical prediction. It predicts that you would see twice as much bending as you would expect to see from Newtonian gravity. And so that's the question. This is a thing that, could it perhaps be observed? And so it turns out you can't see stars during the day, and the biggest source of gravity in our nearby vicinity is the sun. But what you can do is you can see stars during a solar eclipse. So the idea is that you figure out where the stars should be. You figure out where the stars should be when they're not behind the sun. So like you look at them, say in June, when at night you can look at where they are relative, and then you can figure out where they are relative to the sun. And then in December, when the Earth is on the other side, the stars would be on the other side of the sun. But during a solar eclipse, you might be able to see the star's light being bent around the sun. And if it appears like it's in a different place by a certain amount, then that would either confirm or falsify general relativity. And that's what happened. In fact, that's what shot Einstein to fame overnight in 1919. What specifically rules out longitudinal gravity experiment mathematics, or simply the assumptions of GR? It's sort of a combination of them. So as far as we know, we haven't detected longitudinal gravitational waves. I imagine that LIGO is sensitive to these. But the other thing is that we have a ton of extremely good evidence for general relativity, and general relativity rules out the possibility of longitudinal gravitational waves. Gotta hydrate some more. By the way, remember, if you want your question to be guaranteed to be answered, go to YouTube and send a super chat. Then I'll answer your question because they get priority. The other thing is that if you don't want to do that, but you instead just want to become, instead you just want to say, like, support me with like $5 a month, you can become a super fan on TikTok, you can become a member on YouTube, you can become a patron on Patreon, you can become a Twitch subscriber, like $5 a month on each platform. And as part of the perks that you get, they're every Tuesday from 10:30 to noon Pacific time, and most Wednesdays from 10:30 to noon Pacific time, I do a subscribers or members or super fans only Q&A chat like this, so you can get your questions answered that way too. So consider it. You don't have to, but it's very appreciated if you do. Help support, small creators like me, small independent indie creators or something. Anyway, let's keep answering some questions. Why are light particles always in motion by default? Well, they have to be. That's what it means to be light. Physicist, but you don't know anything? I know plenty of things. I just also know what I don't know, or at least I'm quite aware of things that I don't know. From Moha, thank you for the 50 SAR. I actually don't know what SAR stands for. One of the things that I love doing is finding out what... oh, these are Saudi riyals. Okay, good to know. I've never seen Saudi riyals before, but I appreciate it. I would love to know your view on energy. Do we fundamentally know what energy is beyond a useful accounting term? Why does it exist, and why is it conserved from locally? Do we understand it fully? Yeah, so since Nerther came around, we do understand energy fully, and it is an accounting term. That's what it is. It's a conserved quantity. In the same way that momentum is a useful accounting term, in the same way that angular momentum is a useful accounting term. This is it's not really a thing, as at least that's my view. It's just a number. It's just a, like you said, it's an accounting term. Why it's conserved locally, that follows from Noether's theorem. You can see this in GR. You can see this in other local theories. It doesn't have to be conserved locally. It's just there's some the dynamics of our universe seem to indicate that it is. Just from like the equations that we write down for our universe, these are the kinds of equations that obey local energy conservation. But that's the story. And from Jesse Marie Hayes with the $5, what do you think about the idea that consciousness is the fundamental basis of reality versus matter? I don't put too much stock in it. It seems like it's very human-centric, and I'm just not convinced that humans are particularly special. Light, after being stretched by dark energy, loses energy. What if, since light has no time, that energy is actually sent in the past, as that's the start of the light? So light, it's not that light has no time. Light has time just fine. It moves through space-time, no problem. But that energy is just, you're right, that energy is just lost. Why assume that the black hole scrambles other than organize? We typically see more organization with more gravity. Because it seems to work out with the mathematics of the large entropy. Like it just seems to work out that way. But I mean, it's not that gravity organizes, it's that gravity condenses. Now, condensing isn't the same as organizing. You could imagine that, you know, things get very, very hot when they, you know, in the interior of a black hole, things are very, very hot because they're moving. They have so much kinetic energy from falling together and collapsing that they would be bouncing around all the place, and it would be highly scrambled. That seems plausible to me, at least. From G073 Inks 76 with the $5, how does Cherenkov radiation work if light slows down because of absorption or re-emittance? Well, that's not really why light slows down. So that's like a story that you can tell, and it's, you know, partially correct story, but it's just that electromagnetic waves don't. So you don't need any quantum mechanics to understand this. People like to think in terms of photons far more frequently than they should. Photons are not the end all be all of the way to understand electromagnetism, or the way to understand light. So electromagnetism, you can have a wave in an electromagnetic field. That's what light is. And when that wave encounters charged particles, it can make those charged particles oscillate. And when those charged particles oscillate, they change the electromagnetic field. And so what you end up having is the electromagnetic disturbance propagate together with the disturbance of, say, the electrons in the medium that's also oscillating. So they're kind of moving forward together, and the rate at which they move forward is no longer the speed of light, because it's not just a free electromagnetic field propagating, it's now a coupled electromagnetic field to the electrons. And so it's just going to slow down. This has nothing to do with absorption or re-emittance, right? Now, the question of how Cherenkov radiation works, it's essentially just the same reason why sonic booms happen. If you have a charged thing which is moving in the electromagnetic field faster than the electromagnetic fields can propagate, then the electromagnetic field, the part of the electromagnetic field that's actually propagating by coupling to electrons, that will kind of get caught up at the front of the moving charged particle. That's all. It's a good question though, and I appreciate it. I threw an egg and it started floating. Why? Have you considered that you might be magic? God, I'm dropping things all over the place today. Dude, there's got to be a way to get me out of the solar system in a decent amount of time safely. Maybe not. Sorry. How do you know if charge is positive or negative and the north or south pole of a magnet? Well, look, it's just a convention. We just choose electrons to be negative, and then protons are just the opposite, so they're positive, and then we can just choose the magnetic field to be the north magnetic field to be the direction in which the magnetic field lines leave, and we just call that north. It's just a convention. How can a photon be halfway from the sun and be here at the same time in relation to the photon? It's not at the same time. It's not a well-defined quantity. Did you enjoy math in high school? I'm starting my physics major soon, and I'm worried about the math. I did. I had an excellent math teacher in high school. Do you view math as a tool we invented to describe the universe, or is it the actual framework driving it? I think it's a tool that we invented. Are philosophy of science questions allowed? What are your thoughts on scientific anti-realism versus realism? I'm not quite an anti-realist. I'm also not quite a realist. I think that, like, you know, I'm not one to confuse the map with the territory, but I think that the better our maps get, the closer we get to the territory. From Agata Sawinska with the $8 Australian, I appreciate that. Does time flow differently in intergalactic space? It perhaps flows slightly faster. Couldn't we settle for leaving the solar system in an indecent amount of time? We could, yeah, but, you know, the other guy wanted a decent amount of time. From Starship Valiant with the $5, just wanted to say thanks. Watching your videos help bring me out of decades of indoctrination. Well, thank you. That means a lot. That's the kind of thing that makes me understand that this is worth it, right? I appreciate it, and I'm glad that I could be of help. What's your favorite chemical element? Technetium? Are you a meteorological nihilist? Sometimes. Did you consider math PhD or only physics? I only applied for physics PhDs. From Logan B. Wood with the $5, what are your thoughts on fourth order conformal gravity theories, like from Professor Philip Mannheim? So I'm not familiar with the thing that, like, Philip Mannheim's work specifically. But I'm actually quite fond of fourth order conformal gravity theories because in fact, I actually wrote a paper on something that is very closely related to conformal gravity, fourth order conformal gravity, like a year ago. And well, I mean, we're still in the editing, we are in the referee process. But yeah, I would love if they're correct. As far as I know, we have no evidence that they are correct. There's also a problem, like on the physics side, there's a problem with higher order theories because they seem to end up with like, you know, and I'm going to use QFT words that I don't fully understand, but people say things like, oh, you get ghosts, oh, you get anomalies, blah, 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 blah. So like, you know, it's not quite clear that that we can even have a fourth order conformal or a fourth order theory of gravity without doing something special to like fix these alleged problems, right? But I do like I would call it like Bach gravity or something like this, but yeah. Bohmian mechanics valid or not? Well, I'm not a believer in Bohmian mechanics, but some people are. Could a black hole be orbiting just outside our solar system? I've heard the term Planet 9. Could we even find out that it's a black hole? I guess we could if we got really lucky with gravitational lensing. So like if it passed just in front of a star and we happened to notice it, then in principle we could, yeah. From Andros Katona with the 1,000 Hungarian forints, what are your thoughts on information as physical quantum entity? Could the mere generation of information be the trigger for wave function collapse? I don't buy the whole information is a physical quantum entity. I think that like information might be a useful quantity to describe quantum states, but I don't buy that information as a physical thing. Does the cosmological constant error mean QFT vacuum energy is fake or GR fails at scale? I think that it means that QFT vacuum energy is fake. Or just that there's not a cosmological constant. What kind of cheese? What is your favorite kind of cheese? I'm a Swiss fan. Why is entropy not enough for emergent gravity? So I've seen, and I haven't looked into this too deeply, but I've seen papers claiming that entropic gravity fails for non-spherically symmetric systems. Now this maybe entropic gravity people have like pushed on this and have figured out a way to make it work, but it's just, you know, it seems a little far-fetched to me. Do you know what estimate percentage of physics PhD candidates get selected for entry? I have no idea. No idea. Is the universe expanding in all directions at an equal rate? Seemingly yes, but not. Oh, you know, we don't have proof of this per se. How are we puzzled by lava lamps, but climate science is a done deal? So because people have studied the climate way more intensely than people have studied lava lamps. B, the dynamics of lava lamps is arguably more complicated. At least like the fine details of lava lamps is arguably more complicated and can be kind of coarse-grained less efficiently. And C, we actually do understand the basic gist of lava lamps, and understanding the basic gist of the climate would be enough to get you to the idea that indeed carbon dioxide can cause climate change. You don't even need to know the details to know that that's a fact. From Sir Arthur the Great with the $2, please answer Nicola Rulli. I've tried. Am I correct? I haven't seen the question. If particle interactions happen at sea, including ones responsible for bonds, shouldn't an event horizon break all matter into quarks? Thus, no, you wouldn't notice crossing the event horizon. So the thing is this whole you wouldn't notice it assumes that you're a point particle. But what you can do is you can calculate the tidal forces. So it's not that if something is okay, so the answer is no. But so you can just calculate how strong the tidal forces are at the event horizon, and what you'll find is that it can be quite low, i.e. it stretches things by a quite small amount if the black hole is sufficiently large. Now eventually spaghettification will happen because the forces between things, the tidal forces will grow sufficiently large that it'll stretch things out, but that doesn't have to happen at the event horizon. The event horizon is more of a, in some sense it's more of like it's not quite just like a speed limit barrier, right? From Genderbender with the $5, we see you debate with Christians. Have you delved into Eastern religions? Hinduism and Islam revere science and religions together. Thoughts? So I debate Muslims quite frequently. There just aren't a lot of Hindus who come up onto my live streams, so I haven't talked to them a whole lot. And, you know, religious traditions can revere science, but they could still rely on fundamentally non-scientific claims. I appreciate the super chat, though. Specifically talking about the low tidal force scenario. Yeah, so when the tidal force is low, then it just wouldn't stretch things. The acceleration on one particle would not be so much greater than the acceleration on another particle that it would overcome, say, the strong nuclear force. What would you do if someone injected you with a syringe of tree 3? Probably explode. Can you describe in simple terms Penrose's inequality and what do you think about its interpretation? Are you talking about the... Surely you're not talking about the, like, something to do with, like, fine tuning. You mean like the mass inequality, right? I haven't thought a whole lot about it. And so, like, it's not something that I would want to opine on. Like, I don't work in Lorentzian signature quite all that much, and I also don't do a lot of, like, global analysis, and so, like, things like total masses of spacetimes is just not something that I've spent a lot of time thinking about. Although there is a paper that this conformal gravity paper that I wrote quite recently does kind of invoke some of it, so maybe I should familiarize myself. What you atheists have to understand is that back in the Bible days, slavery wasn't outlawed. Okay. I'm applying 2 PhD programs this cycle. My thesis was in string theory, and I may have a paper in it out soon. Should I apply with HEP specialization or more generally? You should probably apply in the thing that you plan on doing. Do you think that there are philosophical aspects of physics that AI won't be able to tackle? Maybe. I don't know. Can't predict the future. Any tips on making a 3D PDE model, specifically dopant diffusion? No, I don't. I am not an expert on like numerical or computational physics. Like, this is just not a thing that I spend a lot of time on. What's the best university to study at? Of course, I'm talking about physics. There probably isn't a best, but, like, if you think of, like, a top 10 of, like, the top 10 universities in the world, those are probably all going to be also top for physics. Global warming is real. Why are scientists not screaming louder from the rooftops how man-made climate change is leading to the existential crisis of humanity? Well, they are. You're just not listening. What's your take on the viability of false vacuum decay? I think it's possible. And as far as I know, the data says that, like, we're, like, right on the brink of it being possible versus it not being possible. So, can you explain the theory of relativity and how it can be used as application for making nuclear weapons? Well, okay, so it's not, like, directly used as an application for nuclear weapons. It's just kind of the core idea of special relativity anyway. One of the core ideas is that the energy that a thing has is not just captured by its kinetic energy and potential energy, but also by its mass. And so if you have this understanding and you can somehow, and then you recognize that different atoms have different masses, despite being, like if you take 2 of the same atom and you combine them, the resulting atom might have less mass, then you realize that there's a lot of energy stored in nuclear bonds. Because the mass differences would account, you know, if you multiply the mass differences by the speed of light squared, then you get the energy, and that's a lot of energy. That's the idea. It's one of the important ideas in relativity. Which one of pre-universe models you go with? I don't have a preferred one, no. What's the maximum dimensions of vector space in LLMs? I don't know. Do you do a lot of climate change debates? That's a subject I find interesting. I do them occasionally. So I do debates that wind up being climate change most of the time on Thursdays. From Moha, with the 25 Saudi rials, it's baffling how energy is conserved locally but not across the universe. I thought I know this theorem. Conserved properties are boggling. Thanks. Yeah, it is really weird, but it stops being weird when you realize that the whole business of differential geometry is that, like, like kind of cubes of space are not glued together in a way that makes them be kind of straight. And so like those deviations, the curvature that space-time has, is what ruins the ability of something that's locally true to be globally true. You think we are closer to the largest thing in the universe or the smallest? I think we're closer to the largest thing in the universe, right? If by the smallest you take it to be like the Planck scale. Oh. What's your job as a physicist as of now? It is an interesting and well-paid job. So my job is I do science communication, I do live streams, and I do research. So, I mean, yeah, it's interesting, and yeah, I make a decent amount of money doing it, but it is a lot of work. I spend a lot of time working, like writing scripts, doing live streams, working on papers, having meetings. You know, I work with several, like, I'm a part of several international groups, so like I'll sometimes have meetings at like 6 in the morning or like 8 o'clock at night, just because that's where my colleagues are. Did James Webb Telescope put doubt on the Big Bang Theory? No. Not sure if this is okay according to the rules of the stream, but I wanted to know what kind of programming knowledge you use as a physicist and what sort of CS you need to know. So you don't. So these days you probably don't need any because vibe coding is a thing. But I did take one programming course as an undergrad. I took a course in Java. I already kind of knew Java because I've always been, you know, kind of computer savvy. So like, you know, I regularly script in Python these days because it's just faster to like, you know, run simulations. But you know, and you know, it's useful to know like some algorithms and stuff like that, but you don't need to, unless you're a computational physicist, then you need to know a lot. I read that black energy are becoming less present in the universe. You mean dark energy, not black energy. I don't know why people confuse black and dark. They're not the same thing. But yeah, so this is one idea, and there's perhaps some evidence that this is the case, but it's not settled. Are you familiar with Sean Carroll's work? I'm excited to read some of his books. I got many emphasis in the many worlds theory intrigues me. Do you have any thoughts on it? Yes, I'm very familiar with Sean Carroll's work. I think that he's a great author, a great science communicator. I've read most of his books. I've read many of his actual physics papers. And it's because of him that the many worlds interpretation seems true to me. So if energy is a universal accounting number that quantifies something, what is it actually quantifying? Well, it's not universal is the important point. It's local, so you can describe a system like a system in a small volume as with a number called energy. But the point is it's just one of the numbers that tells you facts about that tells you about the way that the thing will behave. That's the important feature. Do you think the correct fundamental theory might be permanently unverifiable, blocked by laws? Maybe. It'd be a bummer if it were. Just asking, do you feel comfortable talking about gauge theory? I'm a mathematics student that came across a fascinating issue in physics and math and wanted to ask you for your opinion. It depends if we're talking about like gauge theory in the like quantum sense, or if we're just talking about like classical gauge theory, because I know a bit about classical gauge theory just because it's come up in the research that I've done, but it's not something that I've spent a whole lot of time on. So it just depends on what the question is. What does well-defined exactly means? It really depends on the context, but typically it means something like there are no internal contradictions, and that there's enough data to specify the details of the thing that you're trying to specify, that kind of thing. From Genderbender with the $5, did you end up getting that porcelain object replaced for your wife? So I'm still working on it. Actually, this is a good time to ask. I need to remember to do this. There is a replacement that I can find. It's not an exact replacement, but it's really close. But they only ship to the UK. So if anybody is a follower here, or a member of the Discord, or anybody wants to help me out, and they are local to the UK, I will pay to have it delivered to you, and then pay to have it shipped back to me, and I'll send you some money for your time as well. So, you know, send me a DM on Discord or something if that's something that you might be able to help me out with. From Clanker Plays 101 with the 100 Indian rupees? Are quantum fluctuations the reason behind the Big Bang and the creation of space-time? I don't think so. And it's also not a particularly popular position. We did get a new member from Fletcha7777. Welcome to level 1. Thank you for joining. Was it an important plate? Yes, it is an important plate. Bruh, only answering donations? No, I just prioritize donations. It's pretty obvious why I do that. Are you knowledgeable about electrostatics and potential to use it for thrust? I saw a small company interviewed that states to have made progress in this. Yeah, if a company is suggesting that you can use electrostatics without any ejected mass to produce thrust, then they're selling you a load of horseshit. Like, it's just the reality. How hard is it to get a permanent position in physics research? Very hard. If space-time is an observer-dependent interface, isn't fundamental physicalism a category error? That, I have no idea how to interpret what you just said. Do you believe time is unreal? No. No, I think time is real. Quantum fluctuations as the origins of the universe was more popular as a view of string theory, wasn't it? Not as far as I know. There are some versions of string theory that have like fluctuation-like behavior, but it's not like there was nothing and then there were quantum fluctuations in the universe. I assume as part of your work you watch plenty of other creators. Are there any other underrated or underwatched science communicators that you enjoy? I actually don't. I actually don't watch a lot of stuff. Like I will turn on live streams just like while I'm like doing research just as background noise, but I actually don't. That said, there are two creators on YouTube that I think are quite excellent, and you know, they're going to be the obvious ones. PBS Spacetime is one of the best, and Dr. Becky Smethurst, also excellent science communicator. So if energy is just how we quantify something, what is it actually quantifying? It's not quantifying something, it's quantifying a system. So it's one of the numerical properties that a system has. Do you use Bayesian methods for research, or do you use classical statistical methods? It just depends on the context. But I mean, I typically prefer to use Bayesian methods when possible, but sometimes it's just like, sometimes the kinds of things that I'm doing are just not as amenable, right? Does physicist mean a doctor or a scientist? Physicist is a kind of scientist. Why is energy in GR not well defined? It's not well defined because there's not a unique way to specify what the energy in a space-time is, if the space-time is time dependent, which ours is. I wonder how you feel about addressing electric universe more. I think it's much harder than tackling flat Earth. Electric universe is like falsified by QED, and it's falsified by like GR experiments. Like, it's just directly falsifiable. Why is string theory still being taught? It's obviously not the answer. Well, to say it's obviously not the answer, I think is probably a mistake. Particle bonds not breaking at the event horizon. Are you saying that the outer particle in each pair is sped up enough to catch up to the falling force carriers sent by the other? You could probably... Okay, so the thing is bonds are not like force carriers falling, force carriers bouncing back and forth. That's like a kind of like a cartoon view. Like, there are fields, and those fields those fields exist, and those fields are going to be distorted by the event horizon, but the event horizon is not a particularly special place in space-time. And so the fields can just exist in that area. Is the problem too many physicists or not enough physics to go around? Maybe a little bit of both. How do you think the gravity propulsion device that Bob Lazar was reverse engineering wirelessly communicated its parts with each other? I don't think that Bob Lazar did anything like that. What does cross mean in cross SU3? Or it's SU3 cross SU2 cross U1, and it's just a tensor product. Or rather, it's like a product of groups, which, you know, is giving you it's giving you a tensor product. How do fundamental symmetries give rise to conservation laws and governing rules in physics? They arise from Noether's theorem. Noether's theorem tells you that when you have certain symmetries, you get certain conserved quantities. Now, as for the governing rules in physics, those you just get from variational principles. Yeah, but I meant engaging with electric universe believers more. Flat Earth doesn't need a physicist to debunk, but electric universe does. The thing about electric universe believers is that like none of them know anything, and also there's like there's very, very few of them. Can we see a virtual photon and interact with it with normal photons? No, you can't, because virtual photons don't exist. What resources do you recommend reading for someone who wants to gain your level of knowledge on mathematical physics? I'm finishing my master's next year, going to the space industry with no PhD. Well, if you have a master's, then you already know the kinds of like the way to learn this stuff. So like you pick it up by doing it generally, and by reading things that you're interested in. So like I read a lot of mathematics papers. This is not like if you're finishing up your master's, this is not like there's not like, you know, an online course or a resource, right? Like if you want to learn something specific, then you go and you find the relevant papers or the relevant lecture notes on that thing. Is it possible for us to live without the concept of time? I mean, without the concept of time, sure, but that doesn't mean that time wouldn't exist. Do you explain what information is in physics context and why scientists accept it is conserved? So what they're really talking about is they're in some sense talking about like probability density. They're basically saying that, look, if you have some quantum state that's evolved unitarily, which, you know, is how quantum states evolve if you take quantum mechanics seriously, then in some sense the total probability of all the possible configurations is 100%. And if somehow you were to, and another key idea is that, again, if it evolved unitarily, you should be able to reconstruct what a past quantum state is given the current quantum state. And so if part of your quantum state, for example, falls into a black hole and that information didn't come out in some way, then you wouldn't be able to reconstruct what the original quantum state was, because you don't have the full quantum state out on the other end. And also there's this business with like some of the probability space is no longer part of our observable universe, which would be very weird. From Rodrigo with the $5, just send in $5 for a thank you. I appreciate it, bud. What do you think about physical determinism and most scientists supposedly holding to it? So barring quantum mechanics, physical determinism seems fine. Quantum mechanics may or may not introduce some degree of indeterminism, but it certainly doesn't give us free will. Not sure if you answered this, but do equations show that there cannot be nothing? Thinking about pretty big bang reasons, we don't need to rely on God as creating the first thing. So equations, that's like a philosophical question, not really a physics question that physics can really approach. From Sunopeak with the 25 Arab Emirate dirhams. If we can't even prove or disprove the Riemann hypothesis, how can we prove God doesn't exist? The Riemann hypothesis is a much harder problem, it turns out, than proving God doesn't exist. Do the fields take up space? They're in space. Oh, sorry. How does string theory connect relativity with quantum mechanics? Well, if you look at various string oscillations, one of the string oscillation modes, at least this is the classical explanation, one of the string oscillation modes looks an awful lot like a graviton. That's how. And string theory is a quantum theory, of course. From Rodrigo with the $2, why do time and space swap places in a black hole? That's just kind of what it means for there to be a black hole at all. In order for there to be what an event horizon is it's the barrier between where space and time swap. That's what a black hole is. All right. Oh well, we still have a few more. Still have another minute or so, 30 seconds maybe. From Pseudopeak, again with the 25 Arab Emirate dirhams. According to quantum mechanics, is there a chance this donation would end up appearing out of thin air in my room? Is there a chance? I mean, I guess that there's like a non-zero probability, but like that probability is so astonishingly small that it'll never happen. All right, so it is 10:30. So what that means is I'm going to close down the chats. Everybody can watch, but I'm going to close down the chats to just those who are $5 a month members in the various platforms. And so, you know, this is an incentive. Usually I would end the live stream here, but this is an incentive for people who are followers, who do, who do support me with $5 a month. They get a chance to get their questions answered. I'm also going to open the chat to everybody who wants to come in and ask questions. You can come in and ask questions over audio if you would like to. You don't have to, but this is an opportunity to come in and do that as well. Just give me one moment just to change all the settings, and then we will be good to go, and I will continue with answering questions. Do dude is just trying to make cash. I just did the first hour and a half for free. What? Of course I'm going to incentivize people who are supporting, or incentivize people to support me. That's like, why wouldn't I? What are you doing? Okay, anyway. So that should be all set. We do have a super chat from Logan B. Wood with the $10. As a researcher and science communicator, what are some particularly resilient and pervasive misrepresentations and misinterpretations of your area of research spread by other science communicators? That gravity is not a force. People say this a lot. It's just not real. It's not real. Gravity still allows for momentum transfer. The other thing is that like somehow, and I really don't like the way that people treat string theory. String theory is still worth studying, right? That's not directly my area, but it's still worth studying, even if it's not the true theory of gravity, theory of quantum gravity, or theory of everything. It's still a theory of everything, and that'll still teach us something. All right, so we have gotta backtrack a little bit. What possibly can be the reason why, when an excited atom is re-energized with a photon of the same energy, leads to release of a coherent photon of the same wavelength? I've actually made a video about this. Basically, it's when a photon absorbs an electron traveling in a direction, it's not just that it just jumps up. It's actually like there's actually like a process that it like a transition process, and the excited electron state has in some sense a preferred direction to it. And so because of the like if it's absorbing a momentum, the electron has to gain that momentum. And so when it decays back down to its rest state, that momentum has to be released. And so the question is then, why is it coherent? It just like this is just a feature of the emission process. You can just calculate the coherency. You can just show that like the emitted photon has a higher probability of being coherent than otherwise. But it's a good question. Did scientists freeze a photon, and how can you stop a photon from moving? What they did is they put light in a medium that's sufficiently slow, or that's sufficiently slow that it's effectively stopped. That's basically what they did. If black hole behavior is fully determined by geometry, does that imply mathematics like informational dynamics is ontologically prior to physical reality? Not necessarily. Geometry is just a way of describing, relations, arguably. And so those relations could have ontological priority, and the geometry is the way that you describe them. Dr. Blitz, given DESI, SDSS, and the CMB data hinting at evolving dark energy, when can we expect a definitive verdict on the cosmological constant versus string theory landscape models? I don't know. I really don't know. Hopefully we'll have a whole bunch more data in the near future, but I don't know how long that'll take. All right, let's bring up our first guest, a regular even. Oh, and by the way, you can also join via this Discord URL. I forgot to make that public or make that display. Let's bring up Zeno. Zeno, welcome back, hey, as always. Not a whole lot. What you got for me? It's fine.
Yeah, no. So I know we talked yesterday a little bit about intuition. I was gonna ask kind of a follow-up.
Sure.
Do you okay, I'm going into my first semester. It's gonna be like probably some Young and Friedman, like just general university physics book.
Yep.
But to build my intuition, should I look for a more like advanced classical mechanics book?
No.
What do you recommend?
No. So generally speaking, intuition doesn't come from doing derivations. Intuition just comes from doing problems a lot. So you just intuition is basically what you start to expect, and that's not going to come from a derivation, because a derivation is kind of like a higher order level of processing. Intuition is really what you want to have is just like a baseline that like tells you what the answer should look like, and that it's just a separate useful tool. If you have good intuition, then you can basically save a lot of time and save a lot of effort on correcting or on finding and correcting mistakes. It's not going to increase your understanding, but it will mean that you will have less trouble working out details. So yeah, as far as building intuition, it's just going to come from doing exercises.
Makes sense. And just to be clear, I could still do the Griffiths electrodynamics alongside this, like just for self-study or whatever.
Yeah, you can. Griffiths electrodynamics is it? I want to say it's harder than what you'll find in Young and Friedman, but it's doable. It's an introductory textbook, so you should be fine.
Okay, cool. I guess kind of second question: can I call myself a baby physicist now officially?
You can call yourself a baby physicist, sure.
Okay, good to know. Good to know. All right, well, that's pretty much all I had. Thanks for answering my questions as always.
Sure. All right, good luck. Take care.
All right, thanks.
We have some more questions. What happens to light after it enters the black hole? It just keeps going, right? It'll just fall in. The question is what happens after that? Well, we don't know. Do you think the universe is necessary, contingent, and which would you prefer? I mean, I'd prefer it to be necessary because, you know, that's cleaner. But I'm not, and you know, I think that it, yeah, I'd prefer it to be necessary, but which I think is true, I'm not sure. It's hard to say. Would you consider discussing climate change or on a fortnightly or monthly basis? I do talk about it like once a week, basically, on Thursdays. If we discovered some kind of universal level clock that was the baseline passage of time that relativistic forces dilate, would that help account for why nows exist? Yeah, perhaps it would be the case that like then we do have a universal now, and relativity is just, you know, false. That might give that would perhaps give us reasons to think that a theory of time is true. From Smokey RP, how does the Riemann zeta function work? It's just a function. It takes inputs and gives outputs, but it takes complex inputs and gives complex outputs. It's like the sum from n equals 0 to infinity or something of 1 over n to the s, where s is your variable, I guess. I think that that's the statement, right? S is the variable? Or is n the variable? Yeah, I think it's s. How do positives add up to a negative? Oh, well, they don't. So, okay, so you're talking about this kind of like Riemann zeta renormalization. So there's this idea that you can express the Riemann zeta. You can, you know, one of the non-standard values of the Riemann zeta function is the zeta function of -1, which would be just the sum of the integers, the sum of the positive integers. So 1 plus 2 plus 3, etc. And the point is that that's like obviously infinity. Like if you just plug that into the Riemann zeta function, you get infinity. But what you can do is that you can take, say, a limit as s approaches 1. What you'll find is that the limit diverges. But if you parameterize that limiting procedure in terms of some small variable, say epsilon, you can then do a Taylor series expansion of your Riemann zeta function near epsilon equals 0. And what you'll find is that there's an infinite chunk, some piece that diverges, and then there's a finite chunk. So if you throw away the infinite chunk, then you're just left with a finite chunk, and that finite chunk ends up being like -1/12. Very weird. But that's complex analysis for you, or I guess in this case that would be like real analysis. But from Nathan Irvine with the $5, what do you call someone who steals energy from the museum? A jewel thief. That's a good one. That's a good joke. I appreciate that. And from Beeble, could it be that light is absorbed and unreflected by the mass of a black hole? Well, it is absorbed. It is absorbed. It falls in. That is absorbing the light. Yeah. When does the universe splitting occur? Every time I do something. So the universe splitting is not some objective thing. It's just like a way of understanding when we can say that that decoherence has happened. If multiverse models are mathematically consistent but empirically inaccessible, what counts as real in cosmology? That's a good question, and it's actually like a deep question that needs to be considered. However, I think that there's a sense in which you could say, like, imagine a world, or imagine a universe where we could figure out what the theory of everything is just from local experiments, just within our own universe, within our own observable universe even. We could figure out what the theory of everything is, and perhaps the implication of that theory of everything being true would be that, you know, there is a multiverse. Well, in that case, I think that we would have good reason to think that there is indeed a multiverse, even if we can't access it. Right? Because it would be an implication of something that we've established as true. So I think that it would be reasonable to say that such a thing is real, but that scenario might not be a realistic scenario. It's a good question, though. Gotta hydrate a little bit. Okay, so we currently have no guests and no questions. So instead, I will tell you about a Should I tell you about... Well, if I tell you about a paper that I'm working on, then a paper that I'm working on becomes quite public. What can I tell you about? Actually, let's just count how many papers I'm working on. So I have one paper, which is a kind of a cyclic universe paper that I'm working on with some quite international cadre of physicists. I have another paper that I'm working on with a person that I met on TikTok, which is kind of neat. I have a third paper that I'm working on with some postdocs that are, again, quite international. One's in Taiwan, one's in, well, it's fairly international. One's in Taiwan and the other's in Pennsylvania. I have another paper that I need to get back to work on because we found a mistake in some of them, but in this paper, but that we need to fix. But that's also fairly international, and my collaborators are very busy. Then there's another paper. Okay, that actually I can move that off. I can check this one off. That one's done. There's another paper that I'm working on. I'm working on fixing for the referee report. We're almost done. I haven't forgotten YouTube. Don't worry, I haven't forgotten YouTube. I can see the YouTube chat. That paper is on these things called conformal fundamental forms. There's another paper that I'm working on that involves something called conformally invariant renormalized integrals. And yeah, those are the projects that I'm working on right now. So it's a lot. I have a lot of projects going on. But maybe we'll talk about them when they're done or when they're close to done. Sorry, working on a default judgment, so I'm only half listening. That's fair. Don't worry about it. We do have a guest from Paul Bird, so we will bring up them in a minute, but I just want to answer the questions that came in. I want to study grad level physics and math. What are some good textbooks or resources to work through? I already have a bachelor's in mathematical physics. It just depends on what kind of physics and math you want to do. You could start with any of David Tong's notes. David Tong's notes are very, very good. And they're basically a textbook, but they're not quite a textbook. They aren't really accessible. So like he has a course on string theory. He has a course on quantum field theory. So those could be good places to start. Can quarks in one nucleon affect a quark in another nucleon? Indirectly, sort of, via something like a van der Waals force. This is actually what the strong nuclear force kind of is. What's your most accessible paper to the layperson? Almost certainly none of them. It's just the reality, right? What do you think about J1, J2 spin chains organizing geometry through a Mira tensor network brought on by mereological phase transitions? I haven't looked into tensor network emergence. It's not something that I've spent a lot of time thinking about, so I don't have any opinions on it. From McTime with the question, your research matters immensely. Watching another mentor give 20 years only to be shortchanged was heartbreaking. I'm so glad you insist on being valued. Now you deserve every bit of it. Well, I appreciate that. It sounds terrible. I'm sorry that happened. All right, let's bring up Paul Bird. Paul Bird, how's it going?
Good, how are you?
I'm doing all right. What questions you got for me?
So normally I wouldn't pop on. I know you usually take opposition. I just had a quick question since you didn't have anybody else available at the time.
No, it's not opposition day. This is not there's no opposition allowed here. Not today.
Oh, fantastic.
So go ahead.
All right, so this is strictly a science question.
Yep, that's
it's more of a
go ahead.
More of my ignorance. So I know when we talk about humans, getting on a rocket ship and going the speed of light, that the faster we go, it requires more energy, and to actually obtain the speed of light, we need like infinite energy.
Yep.
So my question is, how does a light particle move at that energy? What kind of energy does it require? And I know that through different states in space, that it sometimes functions a little bit differently. And based off that, how do we actually calculate the origin of the universe based off that particle moving through different things?
So the reason why it would take an infinite amount of energy for something with mass to travel at the speed of light, because things with mass can't travel at the speed of light. It would take, you can get arbitrarily close, but you'll never get there because of, it'll always take more energy, and that'll just get you closer and closer, but never there. That's why people say things like it takes an infinite amount of energy to get to the speed of light. It's not really like a actual true statement. It's just kind of a way of saying it takes an infinite amount of energy, and you can only, or regardless of how much energy you have, you will only ever get infinitesimally close. Now, light, on the other hand, doesn't have massless. So it can have any amount of energy, and it still must travel at the speed of light. And this is just the distinction between having mass and not having mass. Now, okay. I didn't really follow your second question. it seems like like this isn't really related to the origin of the universe, if indeed there is such an origin. So maybe you can reframe it so then I know what you're saying better.
Sure. Part of it might have been my misunderstanding in the first part. I thought light had some mass. I just thought it was like finite. Now, again, my limited of knowledge is nowhere on your scale, and I'm still studying. But doesn't light sometimes move at different speeds based off what it's moving through?
Yes, but then it's not light. Then it's something called sometimes it's a polariton, or it's some sort of electromagnetic excitation that's coupled with the matter. It's not light in the sense that you and I know it.
Okay, is that why we kind of have a range on the date of the Big Bang because of different particles that it might be moving through, or are we pretty confident in that?
No, it's just error bars. Like we can only make certain measurements with certain degrees of accuracy, and so we get a range. You get plus or minus whatever because of the error bars in those measurements. But yeah, it doesn't really have anything to do with the speed of light traveling through different media.
Okay, that was pretty much it. I just recently kind of came across that and it made me think in another argument, and I didn't know enough knowledge about it, so I wanted to be, I guess, more sound in my understanding of it before I made it. And when I Googled it, it didn't really give me a human answer. It kind of gave me a generic book answer, which didn't do anything for my thought process, if that makes sense.
That's fair. All right, well, I'm gonna let you go, but thanks for being here, Paul. Yeah. Take care.
Take care.
Danny, if you're watching, you can't talk to me right now. I'm doing a live stream. All right, we do have another question, I think. A few questions, maybe. From Chaotic Life, I haven't studied any gauge theory, Lie algebra, or advanced quantum theory. Any good resources for those? If I'm interested in quantum gravity, what would be the topics to focus on? So, quantum gravity, I mean, you will need all of this stuff for quantum gravity, but there's a good book that I have, which I think might even be freely available, which is where I learned a lot of the Lie algebra stuff that I know. I kind of had to self-teach it myself because I didn't, or self-teach myself Lie algebra. And so this was a good source for it. Let me see if I can find it. I think it was by Glashow. And I'll pull it up so then you can take a screenshot or something. Where is it? I know it's somewhere. Oh, not Glashow. I'm sorry. It's by Georgi. And this is the one that this is the one that I think it is. So let me show you. So this is the book. It's called The Algebras and Particle Physics. It's going to be a good, it's going to be at least in my view, it's a pretty good place to start. It covers a lot, and I think it's freely available, or if it's not freely available, you can definitely find it freely available. And it has a really, really good expository section on, sorry, I have to sneeze. Has a really, really good expository section on Young tableaus, and has a really, really good expository section on where is the section on? It is on Dinkin diagrams, yeah, which is really handy. It was handy for me anyway. So I would recommend this book, at least as a place to start. Then we have, even though you're a Cisco doo-doo head, I've been researching and trying to phrase my questions right, so I'm probably like 5 minutes in your past. Fair, no, that's fair, that's fair. I also don't even understand stuff. Oh. Since our call last week, I bought a lab coat and have been annoying my family, telling them I know best and they must listen. They now officially find me insufferable. Well, you didn't need a lab coat to do that. You could have just told them that anyway. All right, let us bring up another guest from Discord. Let's bring up Asmodan, who's been waiting quite patiently. Thank you so much for waiting here. Asmodan, you're on the show. Gotta unmute yourself. Howdy.
Much.
What you got for me?
I hope to be a fairly simple question, but I don't know if you dabble in the realm of like an attachment to consciousness to materialism. Though
sorry, you don't know if I dabble in what?
An attachment to consciousness to materialism.
Oh yeah, I mean, like that's a philosophical question, not really a science question.
Absolutely. Though I recognize, are you aware of any good arguments for like a consciousness without material?
Besides the a priori ones that, like, you know, we have this conscious experience and therefore we should assume that that's fundamental. No, I don't really know of any particularly good arguments.
Yeah, respectfully, because thank you so much.
Okay,
I
fair
appreciate
enough.
it. Have a great day.
Take care. All right, let's bring up another guest. No, actually, we have some super chats, and then we'll bring up another guest. What about the time dimension allows a mind to proceed through it in moments? Could a brain exist that sequences the world spatially? I don't think that a brain could exist that sequences the world spatially. At least I don't, because like the thing is it would be like, it seems like it would need to be lower dimensional, and it's not clear to me that you could have sufficient complexity to be lower dimensional, to be sufficiently, like if you were just talking about like a 3-dimensional spatial brain that processes sequentially spatially, then it would have to be a 2-dimensional brain that kind of does the processing in the 3rd spatial dimension. And I don't know if you can have enough complexity. Maybe you could have enough complexity in like a 4D spatial brain to like process sequentially that way. But the whole thing about time is that it seems to be ordered. There seems to be a direction, and it's also distinct from the spatial directions, and so that gives us a little bit extra. But importantly, the reason why it seems like we proceed through time sequentially is because memories seem to accumulate sequentially, and those can probably be explained by entropy, namely that you can remember the past because, you know, lower entropy states tend to leave behind records, which we would call memories. From Happy Mansplainer, do climate models use Arrhenius's equation to calculate CO2's warming of our atmosphere? I don't know off the top of my head. All right, let us bring up Duna. Duna, how's it going?
Oh, hi. Can you hear me?
Yeah. What questions you got
Oh,
for
yeah.
me?
So I had a question around time you were just talking about. It's
Mhm.
kind of a bit weird. So basically, physics, to my understanding, tends to reject the notion of like backwards time travel, usually because of paradoxes, to my understanding.
Yeah.
So I was going to ask you, do you believe in like meta time, and does physics back that in any way?
I don't know what you mean by matter time.
Sorry?
What did you say matter time?
Sorry, background note. I said matter time,
I
like
don't know what that
hyper
is.
time, so where like there's a higher dimensional time in a sense.
As I don't think such a thing exists, and as far as I know, there's no evidence. There's no like models in physics that indicate such a thing.
Okay, now that was just my question, because I wasn't sure if that's strictly just kind of locked in theory or if there's any hard evidence in physics.
Well, it doesn't
that
seem like it's not even like a physics theory. It's like not even like a thing that people are theorizing about in physics.
You haven't heard of anyone say something along the lines of like, if you went backwards in time, you would still be in the future. You would just be in a different timeline in a sense.
That's like a Marvel thing, not really a physics thing.
Oh, really? Okay.
Yeah.
That was my only question.
Okay. Well, thanks for being here.
Thanks.
I irritate my family in yoga pants. I don't do yoga. Fair enough. What do you think about massive gravity? I'm a little skeptical, but like, you know, it could be right. I think it's worthwhile for that. I think it's worthwhile that people are working on it. In fluid dynamics, why do we assume that fluids are a continuum? Because it's a good approximation, because it turns out that the scale at which molecular interactions take place is much, much, much smaller than the scale at which we're typically trying to describe fluids. So it's a good approximation. In fact, I think one of the people who won the Fields Medal this year won it for precisely kind of proving that the continuum approximation is a good one. Something like that. All right, let's bring up another guest. We have a guest whose name is something like the Euler-Lagrange equations.
Yes. Hi, Blitz.
How's it going?
Good. How are you?
I'm doing all right. What questions you got for me?
Yeah. So my first question is, I guess, with commutators.
Yeah,
I guess
sure.
The physical intuition in like quantum mechanics is that it kind of tells you how quantum some operators are going to be, or like, you know, if they share eigenstates. But
Yep.
like outside of that, is there any other kind of intuition that you have for commutators?
I mean, the way that I think about them is something like, I mean, operators are projectors, right? And so all the non-zero commutator is telling you is that if the projectors don't commute, then all it's telling you is that outcomes of experiments are not going to commute when you look at their look at their outcomes in kind of different lenses, if you will, or in different lights. You're just not going to get the same thing regardless of the order that you perform the experiment in.
Like Stern-Gerlach type.
Sorry, one more time.
Like a Stern-Gerlach experiment.
Yeah, and yeah, it's exactly that kind of thing. And so, like, you know, I don't know if there's more intuition beyond just thinking of them as like non-commuting projectors, like where the projection actually affects the state. I mean, of course it does, because projectors are, you know, they don't preserve the state; they're a projection. So you know, the information that you have available after you do a projection is reduced, and it's different. So, you know, I don't know. Maybe that's the intuition I have, and that seems like it's enough for me. But maybe it's not satisfying for you.
I think that makes sense. I think that helped. And also there's a link between like Lie brackets in classical mechanics and
Yep.
commutators in quantum mechanics.
Yep.
Is there any like, I guess like, obviously there's like a link between them, but kind of in this physical intuition.
Yeah, so I actually really don't have a good physical intuition for Lie brackets and like symplectic geometry and like Hamiltonian mechanics. It's not really evident to me what they mean. So I don't have a particularly good intuition there, so I wouldn't be able to give you an intuition for the connection between the Lie brackets and the commutators.
That's okay. Some things are fun to just figure out on your own.
Yeah, sorry about that.
No,
by the way, there is something that's worth talking about, or that's worth mentioning if you're interested in this. There's something called geometric quantization, which is kind of an attempt to go from really like the symplectic geometry view of classical mechanics to quantum mechanics by deforming the Lie brackets and kind of by adding a term proportional to h bar. It's fairly sophisticated, but it might be the kind of thing that you'd be interested in looking at if this is a question that you have.
Okay, I'm gonna type that into the search bar so that I just have that later. But just very last thing, quick.
Yep.
Lagrangians, like at the very basic level, when we talk about Lagrangians, we talk about kinetic minus potential energy or something like that. But that's not how you can't always define them like that.
Right.
And they're necessary for defining your actions so that you can know everything about your system, at least classically. So when it comes to defining Lagrangians, is that just kind of, do you just like vibe that out, or
yeah? Well, so there's actually like a theorem. This is like a theorem in mathematics, at least as far as one-dimensional problems are concerned, that you can actually prove, or you can classify, or you can prove that certain equations of motion can, like, there exists an action whose variation gives you the equation of motion. And, you know, there's certain constraints, like certain constraint equations on the equation of motion, that if those constraint equations are not satisfied, then there is no Lagrangian that gives you such an equation of motion. But as far as like what people do, how people come up with actions, I guess there's kind of two ways. One is like somebody might just think, I wonder what happens if you add this to your action, and they just add a term and then they vary it and they see what happens, and they, you know, now they have a new theory named after them. The other thing is that somebody might have some expected behavior that they want to reproduce at the level of the equation of motion, and then they work backwards to try to find an action that reproduces it.
Okay, yeah, because that's exactly how my advisor did it. And, and so I was like, how did you know to do that? And it was very cool.
Yeah, I mean, like, in my view, it's hard to say that the action is actually something fundamental when people just make it up. People just like write down a formula because it does what they want it to do. Like, there are a lot of actions, or no, what do I want to say? In some sense, we really should think of the equation of motion as fundamental, and then the action is just like a compact way of expressing it and of, you know, learning about it.
Mm-hmm. I see.
At least at the level of
Yeah.
classical mechanics. At the level of quantum mechanics, the action plays a deeper role, but that's neither here nor there.
Yeah, I guess to me the action is one of the, even if you can kind of just like make it up, that I see why you think that it's hard to believe that it's as fundamental. It does the fact that it's also like its role in quantum mechanics is that kind of, does that change your mind about it like as a whole?
It's hard to say. So like,
Mm.
at least it seems like any statement that you can make about the action, you could probably derive from just the equation of motion. And so maybe it's not fundamental, maybe it's just like a compact way of expressing an idea. Hard to say. I'm kind of on the fence about it, to be honest, but like I'm generally of the view that it's kind of like, if you can just make it up, like you know, it's not like you know, Einstein came up with with the equations of motion for GR first, and then he and Hilbert tried to find an action that gives those equations of motion. Now it happens to be that that action is really simple and really clean, so maybe there's some importance there that like, well, simple actions are better, but like I think Einstein probably still would have written down GR even if the action was horrible. So
Yeah,
I don't know.
that makes sense. Yeah, okay. Well, thank you for your time.
Yeah.
And when do you do Ask a Physicist, like?
Tuesdays and Wednesdays, 9 a.m.
All right,
9 a.m. Pacific time to around noon, depending on whether I have meetings.
great. All right, well, thank you so much.
Of course. Take care. Oh, shoot. I just left my own... Dang it. There we go. Okay, I fixed it. Okay. We have some more questions, then we'll bring up another guest. What similarities are there between fluid dynamics, Bernoulli's principle, and AI brain networks? I have no idea. I don't really know anything about AI brain networks, like at all. What is the mechanism to split the universe, i.e. at breakfast? Well, so the universe doesn't really split. What happens is that decoherence happens, and that decoherence happens whenever you have a large quantum state that's able to interact with the environment, interacting with a large macroscopic system that's able to interact with the environment, interacts with a small microscopic system that's, in a superposition, for example. What kinds of things in physics does the number line or number theory in general fail to describe? Wouldn't this trait push something outside of physics as we use it? Hard to say. I mean, there are things more general than the number line, like, tensor structures and smooth manifolds, but like those are like all generalizations of the number theory, of the number line. So, it's not so clear, actually. Do you think eternal inflation is a viable cosmological model for a multiverse? Viable, maybe, or viable, maybe not, but plausible or possible, sure. Just want to double check something. I want to make sure that I didn't miss any membership joins. Okay, let's bring up another guest. I think Inuuep has been waiting for a while. Inuuep.
Oh, hey.
Hey, how's it going?
Going good. I'm not a physicist, but just a general thing. I got two questions.
Well, if you were, you probably wouldn't be asking me questions, so makes sense.
Yeah.
What you got for me?
So I'm this is something I've just been curious about. If there's virtual particles being created and there's vacuum energy, doesn't that violate the first law of thermodynamics?
Virtual particles are made up. They're not real.
Oh, I thought like they're still popping into existence and then they're annihilating each other, but that's still creation.
This is an intuition that went too far. They're a mathematical trick. They're used in like calculations. These things, but they're not actually there. Nothing's popping in and out of existence unless there's like actually like a source, and then you have real particles that are actually doing this. And those real particles would have energy associated with them.
So it's just it's like a math trick or something for the
Yeah.
it's not real actually. There's nothing
Right.
that's popping in, destroying itself, and then going away.
Yep, not real. Actually made up.
What about vacuum energy though?
Vacuum
Isn't
energy.
that-
Vacuum energy is non-zero. Or it's seemingly non-zero, but it doesn't really have anything to do with particles popping in and out of existence. It's just that every single possible particle state, even when there's no particles in that particle state, has energy.
But isn't it like creation of energy? Like, isn't it coming out of nowhere? So couldn't like
No.
like a super intelligent species harvest it, or it's not like
No, it's not
something
coming out
that's
of nowhere.
tangible?
It didn't. It's not like it's not like it didn't used to exist and now it does exist. It's always been there. But no, it's not harvestable. The vacuum energy is by definition the kind of energy. It's the lowest amount of energy that the system can have. So if you were to harvest it, you would somehow be taking that energy away from the vacuum, which would mean that it would be in an even lower energy state. But if it were in an even lower energy state, then the vacuum energy wouldn't have been the lowest energy state. So no, it's not possible for something to harvest it.
So it doesn't like affect the total like mass energy of the universe.
It
That's
plausibly
like-
does. Some people think that this is actually the explanation for what dark energy is. But that doesn't mean it's harvestable.
No, I just meant to kind of like, because if you have a system and and you're able to just take the energy out, and then even if you go up, it's like if you like went up a level and then it still can't explain where the energy is coming from, then it's a violation. But then I realized now, okay, so what you're saying is that it's not harvestable and it doesn't like affect the total mass energy.
No, but it does affect the total mass energy of the universe. It does.
It's already included. Sorry, it's included.
Yeah.
Basically. Okay, got it. Because I thought the cosmological constant, there's a discrepancy by orders of like 110 to the 120, something like that.
So this is one of the potential issues with this is one of the potential issues with the explanation that dark energy is caused, or that dark energy is the vacuum energy, which is why I'm a little bit skeptical of that claim. But some people still think that it's reasonable, that we just need to do our quantum field theory correctly, and then we would see that 10 to the minus 120 falls away.
Oh, okay, got it. And then my second question is, isn't it kind of like trippy, like that we have 3 generations of particles, but for the electron, isn't the second and third they decay in like
very quickly,
like nanoseconds, micro, yeah. And then so we only like all interactions in the universe are only using the first generation of electron.
Yep.
All like, so isn't that kind of like weird?
Well, and the first generation of quarks.
And yeah, that too, yeah.
It is. I mean, I don't know if it's weird. Like, the point is, if it was using the second generation, then we would have called the second generation the first generation. The point is that, like, of course, the interactions are going to depend on the things that are most stable, and the most stable things are going to be the lightest. So maybe it's not so surprising.
Oh, okay. But it's just because of the decay time is so fast. It's almost like it seems like it's never going to be used in every. It just seems kind of weird that it even exists in the first place. But I guess that's just how it is, basically.
Well, there is something to be said that, like, even though those other generations of quarks and leptons, they don't last very long, except the neutrinos, by the way. The neutrinos do. They don't seem to decay.
Right.
It seems like their mere existence does affect things. For example, you're able to have CP violation in the weak nuclear force because there's 3 generations of particles. If I remember correctly, this is there's a term that shows up in the CKM matrix, which requires that the CKM matrix be at least 3-dimensional, which means that there has to be at least 3 generations of quarks. Otherwise, you couldn't have CP violation, and CP violation is perhaps one explanation for why there's so much matter rather than antimatter. So, even though they don't play a role in like everyday interactions, the existence of these things do play a significant role in the way the universe is.
Oh, okay. I didn't even consider that.
Yeah.
But is there a reason it stops at 3, or we don't know?
There might be more.
That is
we just haven't detected them.
Oh, okay. So,
although if it stops at 3, that'd be quite nice.
Have we? So, I mean, if it keeps going, would it be even harder to observe them? I'm guessing the
heavier they are, the harder they are to observe.
Small.
Yeah.
Yeah. Okay. I have one more question, but if it's
sure, no, you're fine.
Okay. Yeah. So, like I heard that AI is like the cloud solving the Riemann hypothesis, like it's doing some of the Riemann hypothesis for math. Do you think AI is going to do the same thing for physics? There's certain problems that like you can throw AI at it, like cloud, and it will or you
Maybe,
think it's just
but just for the record, the AI is nowhere close to solving the Riemann hypothesis. It's not close in the slightest. The result that came out does not help solve the Riemann hypothesis at all.
it bumped
So-
the percentage of confidence, right? Or something.
No, it's not a percentage of confidence. It's just like they proved they improved it on a lower bound of the number of Riemann zeros that fall on the critical strip or that fall on the critical line. But the point is that even if they showed that it was 100%, even if AI could prove it was 100%, that still wouldn't mean the Riemann hypothesis is true, because 100% of a like the number 6 is 0% of all of the numbers, but the number 6 is still exists, right? So doing any sort of statistical bound on the number of zeros that fall on the critical line will not get you to solving the Riemann hypothesis. So like it's like an interesting result, but it doesn't help at all to solve the problem.
Oh, okay.
And,
but for
in physics, maybe. The thing about solving physics problems is that it's rarely an issue of like not knowing how to do the math. It's usually like a conceptual breakthrough that you need. And so I kind of suspect not, at least not until AI is better at doing that kind of conceptual breakthrough, which, you know, maybe it will be eventually in the future, but it's not yet.
Oh, okay. I see what you're saying. Okay. Yeah, that's So so I mean, if AI gets smarter, like than physicists, or at least approaches the same level of conceptual breakthroughs, then it will. But aren't there certain problems that kind of be like brute force that like or that's not like considered solving if you like brute force it to prove
I mean, like I'm sure that there are problems that you could like kind of brute force. And you know, but those are not going to be like major problems, right?
Oh, I got it. Yeah. Like why the 3 generation? That's not like
that's
like
not a problem that you can brute force.
Oh, okay. Got it. But yeah, those are my questions. Yeah, thank you so much.
Of course. Thanks for being here.
Yeah, of course. Yeah.
Oh, I kicked him a little early. We do have some more questions, so let's answer those. Can you explain homotopy type theory? No, because I don't know what it is. Do we know that our universe is in a false vacuum state, or is that postulated? It's postulated. So you can go look. There's actually a nice chart. Let me make sure that this is the chart that I want. Yeah, okay, it's this chart. So, oops. So this is a graph from, you know, we have LHC data, we have we have Tevatron data and so on. Of this is the mass of the Higgs boson compared to the mass of the top quark, and so these relative masses definitely affect whether or not we are in a stable state or a metastable state or an unstable state. And it looks like we're kind of like right on the right on the boundary between stable and metastable. It seems like that we're probably in a metastable state, but you know, it's definitely not confirmed, because like there's higher energy physics that could play a role here that we don't know about. What would happen if I got rid of the moon? Lots of people would be very upset with you. All right, let's bring up a guest from TikTok. Miriam has been waiting quite patiently. Ow. Miriam, how's it going? Miriam?
All good, Blitz. How are you doing today? Miriam, yes.
Great, Miriam. So I'm doing all right. What questions you got for me?
I had a bit of a speculation, like thought experiment idea that I had going on, and if you're willing, I'd be happy to bounce it off of you. I was thinking about kind of existentialism, like why does stuff exist rather than other? There are other lives about it, and we were talking. And best speculation I've got is that at some point, for example, in the example of like how nothingness may not be able to possibly exist in the far future, once you know inflation or expansion of the universe has continued for trillions or quadrillions of years, you might find some point somewhere in the middle of like a void, like the Botez void, somewhere in the middle of that spot, you're going to have a region of space where there is no longer, where like the light cone of objects, particles, photons entering into that region of space is just no longer empty. Everything's expanding away past the point where they're ever going to get into that region of space again.
Yep.
And at that point, right, I was just kind of imagining like that barrier as almost like the like a white hole, kind of like a variation of a white hole. Like nothing's ever going to get into that spot. But I mean, if
but it's still not nothing.
Right. And I was thinking about like the possibility, like if you you know, crank the clock of time faster, forward, faster in time, but you don't have any matter there to like interact with itself to measure the ticks of a clock, of a material clock, then, you know, any span of you know, a blink of an eye to eternity is more or less like kind of the same.
This is an idea that Penrose has in his conformal cyclic cosmology, by the way.
Oh, okay. That's exactly what I was going to ask. I was like, I feel like somebody's probably like thought about this sort of thing. I just don't know exactly where.
Yep.
Yeah. Okay. So kind of like Penrose's if I understand the diagrams that are like showing the boundaries of like the event horizon in a straight line, the one of those cycles, you know, crossing the 45 degrees in what, but in like, you know, you go up left, up right, and in that cycle, or sorry, that region.
I think you're thinking of the wrong Penrose diagrams. So there are Penrose, yeah. So Penrose's conformal cyclic cosmology is not the same as, like, there's no event horizons involved. I mean, okay, I guess there are event horizons in a de Sitter universe, but not, well, they're cosmic horizons, not really event horizons. There's not really any black holes involved here. But yeah, if you look up conformal cyclic cosmology on Google Images, you will find diagrams that might elucidate what you're referring to.
Awesome. Well, thank you. You know, that was the big question that I had. You know, all this, of course, barring that there's a big crunch and everything just crashes back.
Sure,
together.
of course.
For sure. But yeah, you know, love your stuff. Keep on keeping on, and I hope you have a great one.
Appreciate it. Thanks for being here. From Lizards Everywhere with the 1337 euros, thank you so much. Higgs mechanism gives particles mass, causing them to not be able to move at c, and not moving with c means experiencing time. So does the Higgs mechanism cause time to exist? No. Photons still exist in time. All having mass means is that you have a non-zero proper time. That's all it means. But proper time is not the same thing as time simpliciter. Common misconception. Hi, I'm new. Danny Stockman, welcome to the party. Glad that you're here. All right, let's bring up another guest. Talk to, I think McTime was next. McTime, welcome back. You gotta unmute yourself.
Hello,
There
can you
you
hear me?
Yeah, I can.
Good doctor, how you doing, good doctor?
I'm doing all right. What you got for me today?
I got two more. Let me turn this thing down. I got two questions. One of them is a debate tactic question, but the first question is you may have touched on it earlier, but I heard you was talking about cyclic universes, and I want to know your thought on the epoch. I think it's, I can't hide behind the computer to disguise my language, but the eporodic cyclic universe model.
Yeah. Yep.
With the dark energy. The dark energy is the creator, basically the creator and destroyer of universes. Well, what is that? Do I have that right?
Well, creator and destroyer is probably too poetic language, but the idea is just that in the ekpyrosis, so I think ekpyrosis means like fire or something, or like conflagration or something in Greek, which is where the name came from. But the idea is just that an ekpyrotic universe can have extremely rapid compression that kind of does away with all of the information from the past universe. So you get an expansion and then you get recompression, and it's sufficiently fast that it basically does away with all of the information from the previous cycle. So it kind of like cleanses it in fire, if you will, and then it's reborn. And then there's another universe that comes out, or then it bounces off, and then you get another universe expanding again. You know, the universe never ceases to exist, though. It's just like the information is kind of wiped clean.
Yeah, like your chalkboard you like to sit in front
Exactly.
of.
Exactly.
You wipe it clean. But I'm talking about the one this particular theory I'm talking about is where you know, like the dark energy pushes everything apart and but after you know, in the infinite long time after everything has been pushed apart, the dark energy becomes matter again, and that's the version that I was talking about. Are you familiar
I'm not
with
familiar
that
with
one?
that. Nope, not familiar with it.
Okay. Well, yeah, it was on. I know I'm saying it wrong, but it was on an episode of PBS Space Time, and I remember you was talking about that earlier. The debate tactic I want to the debate tactic I wanted to ask you about is I like to point out that in Jeremiah, we were debating Christian steers in Jeremiah that because I got this from your boy Justin, that Jesus was where Matthew it says he's the son of or he's a descendant of Jeconiah, and in Jeremiah it says that Jeconiah comes from a cursed lineage.
Yep.
And now I'm aware of there's some kind of a way to get out of the curse in Hagar, and I forgot exactly how they said it. It was something like and I got some rebuttals to it. Like it's a like a political thing. In Hagar is not really reversing God's curse as far as I got in the rebuttal. But I was wondering, do you think that's just fair of me to bring that up, even though I know that they got a way out of it? And
okay, look, if we're being entirely honest, if you think that their way out of it is legitimate, then you shouldn't bring it up, because then you're just looking to win a debate based off of how little your opponent knows, rather than actually trying to, like, you know, make an actually valid point. However, if you think that their rebuttal, their way out of it, is kind of like not a good solution, then yeah, feel free to bring it up, as long as you have a response, as long as you think that there's like actually a response to the solution that they offer, then yeah, I think that's fine.
Well, see, and you could tell by the way I explained it that I barely know enough to rebut that. But
I wouldn't bring it up if you barely know enough if you barely know the topic well enough.
It just feels sleazy to me the way it is, because it seems like it's a political type issue when these are supposed to be divine commands from God. There's a divine curse in Jeremiah, but
sure,
political issue in Hagar. But yeah, that's basically how I got it. But thank you, Dr. Blitz. I appreciate you taking your time.
Of course. And Cisco's better, by the way. From Danny Stockman with the question. Been looking at the Hubble tension in the JWST early galaxies. What do you think is causing the mismatch from standard cosmology? So I think that these are just caused by different things. I think that the Hubble tension is just caused by the fact that that our universe is not best described by a cosmological constant. That there's probably some sort of dynamic dark energy that's a better explanation. As far as the early galaxies, this is just a failure of ours to understand properly what early universe galaxy formation looks like. Like, all of our data prior to the 5 years ago came just from looking at galaxies in the late universe and how they formed. But there's no reason to say that like galaxies have to form the same way in the early universe as compared to the late universe, right? Been thinking that maybe you could account for some of it by using Einstein-Cartan torsion back into Riemannian geometry. From my understanding, Einstein settled on Riemannian geometry because it was good enough. Yeah, I mean, maybe, but the Einstein-Cartan torsion stuff doesn't really play a role until you get to extremely high densities, and then there's that's probably irrelevant for the density that the universe had when these early galaxies were forming. It is over 5 sigma discrepancy, and I think that discrepancy, the cosmological or the Hubble tension discrepancy, comes from the fact that we're using the wrong model. I think that we probably need a different non-constant dark energy source. Just gotta double check something, make sure that there's no cash apps or super chats or anything like that. I always forget to look at those on a regular basis. All right, let's bring up our next guest from, there's more questions. From Lele, can we see the edge of the universe with a telescope? We can see the edge of the observable universe with a telescope. The telescope has to be a radio telescope, but we can see it. That's how we see the cosmic microwave background radiation. All right, let's bring up Pius.
Hi.
Hey, how's it going?
Lovely. Wonderful. How about you?
I'm doing all right. Pius, what questions you got for me?
So I'm currently studying computer science. Actually just got home from an exam today.
Hope it went well.
I'm particularly intrigued with theoretical computer science, and I was wondering whether if we had a proof for P equals NP or to the contrary, would that affect our understanding of physics in any way?
No, not in the slightest.
Okay. Because like I looked it up, and like some sources said that it would like have massive impacts, and some said it would have no impact at all.
I mean, the only thing that I could see it doing is that if there's like some sort of constructive proof that shows that like these hard computational problems can actually be translated into easier or faster computational problems, then like we might get better at like simulating things, and so we might be able to do better simulations, but it wouldn't actually like affect our understanding of physics. It would just maybe make us better at doing physics research.
Yeah, that makes sense. I thought it would probably be something like that, but you never know.
You never know. Anything else?
Exactly. No, I just wanted to say that I really appreciate the work that you do, especially on like the Christian stuff, the deconstruction stuff, because I'm an extra Christian myself, and sometimes I feel like we're so fucked because religion is just hindering us from getting further as humanity. And the work you do, and obviously Justin and Ian and other atheist TikTokers as well, it's so refreshing. It gives me the slightest bit of hope, and I really appreciate you.
I appreciate
that's
that.
all.
Well, have a good one, Pius. Good luck on your future exams, and I hope that you did well in this one. All right, we do have a super chat from Pi 3.1 with the $20, which is very generous. Thank you, Pi. Pharaoh, the answer is concepts like prime numbers, divisibility, and solving equations with integer solutions in number theory is intrinsic to the design of scripture. Look up John Elias, Proof of God. I don't know what this question is saying. I don't think it's a question, actually. But okay, I do appreciate the donation, the super chat. When you add torsion to a static force shield black hole, you get a Kerr singularity. The centrifugal force push the singularity into a torus where all geodesics are not destroyed. Yeah. If a universe is spinning in a similar fashion, I'm wondering if the centrifugal force of the spin would cause dark energy. No, not really. So the reason why this happens in a black hole is because a black hole has extreme density, but our universe doesn't have that extreme density, so the torsion effect would be negligible, right? What's the difference between astrophysics and regular physics? They both deal with lots of math. Yeah, so astrophysics is a subset of physics in some sense. They deal specifically with the physics of stuff in space. That's not all of physics, though, of course. For the Bible thing, the story where Hagar gets the divine promises in Genesis 16. Okay. It just says that she will have many descendants and that her son will be a wild ass of a man that everybody hates. That's funny. That doesn't get you to Davidic kingship or to the priesthood or any such messianic trait. Oh, they're responding to a chatter named Sparrow. Okay. Some of your guests have extreme density. True. No, but the thing is that locally, like, you don't get to extreme densities anywhere except inside black holes, and the insides of the black holes can't really affect the outsides of the black holes for, you know, censorship reasons. Let me bring up another guest. At a large enough scale, how would we know? Legit curious how you can dismiss this. Look, so Einstein-Cartan gravity has this very specific relationship with density. And so the relationship with density falls out like you can just plug it into the like you can plug in Einstein-Cartan gravity into the Friedmann equations, And what you'll find is that without a cosmological constant, it just doesn't reproduce the world that we live in. Like, it doesn't expand. It doesn't do the stuff that we need it to do, right? All right, let's bring up David 9393 from Discord. David, you're on the show. You gotta unmute yourself though. David? David, you there? Okay, not David. Let's talk to Dr. Perfidious. What a name. Dr. Perfidious. Howdy.
Hey, how's it going?
Going all right. What questions you got for me?
So it's a question relating to special relativity. I just want to get my intuition right on this because I've been thinking about it for like over a decade. So, you know how when something's going at a constant speed, not accelerating, then we just consider it at a rest. Like basically, its relative frame is at a rest, right?
Yeah,
like,
it's in an inertial frame. Yeah.
So then, let's say I launch a spaceship that can go like 0.2 c.
Mm-hmm.
And then so I accelerate that spaceship up until let's say like a fraction of that. And then basically like from what I understand, if they stop accelerating, then their frame is inertial. So how do they know at what speed of c they're going at, basically? Because like to me it's
that speed is just it's always like speeds are always relative. So you could just look at how far or how quickly something is moving away from you, right?
Right. But like let's say I guess my question is like if you take so I guess the person from the initial frame, so like let's say the spaceship analogy, the planet, the people observing it could see you get up to that speed.
Mm-hmm.
But then for the people in the spaceship, if they stop accelerating, then to them they're not accelerating, right? So like they don't really have any speed in their relative frame.
Yeah.
So then when they start accelerating again, like how would they know how close they are to C, basically, without just looking back at where they were and going like, oh yeah, we're going this speed now?
What do you mean?
Because like that was their. Oh,
so are you saying like how do they know, or how does like the physics know to not let them go faster than C or something?
Yeah, because like like to me it seems like okay, so you can go.
You can just accelerate. You can just accelerate forever, and you'll never get to C. And this is just like they're acceleration basically tells you how much to like tilt your world line. So like if you're not moving at all, you're moving in a vertical line. Think of like time moving up and space moving horizontally. As you accelerate, you're tilting your world line. And once you get to 45 degrees, you're moving at the speed of light. And the point is that depending on how strong your acceleration is, that just tells you how quickly you're tilting. But as you get closer to 45 degrees, it's just you tilt more slowly, regardless of whatever reference frame you're in. But you can, like, from your own perspective, you can always accelerate however fast you want. It's just
so
other people will never see you get faster than C, and you'll never see anybody else get faster than C.
Right. Okay, that makes sense. Thank you. I appreciate that. It makes a lot more sense.
Of course. Anything else?
No, that was all. Thank you.
Okay, take care. So I tend to see a specific geometry in my head, and I'm trying to map it out to what I see in the universe, but that doesn't mean it's reality, which is why I'm here. I need a red teaming against me. You should check out Universe Sandbox. It's like a simulation game, but for space. Yeah, I'm familiar with it. Steinhardt-Turok model: dark energy dilutes space, then decay into potential energy that collapses into high energy, high density matter and radiation, sparking a new Big Bang. Okay, no. So, this is yeah, I know what you're referring to. So it's not that it like so there is some reheating that happens, and that's how you get matter from the from dark energy. But it's not like the dark energy, it's not like it's causing it to expand. And this is not dark energy in the usual sense. It's an ekpyrotic field that decays. During the crunch, it does a reheating thing. But yeah, I know what you're referring to now. All right, let's bring on Asymptotic Darkness, who I believe I've spoken with before, but I feel like it's been a while. Asymptotic Darkness, what questions you got for me?
My position is that black holes don't exist. Well, technically, something like a black hole exists,
Is this
but
a question?
it's not really a black hole.
Is this a question?
Have you read my paper? I sent it to you.
No.
Okay, my question is, if I were to propose that it's actually white holes that exist and not black holes, what would your position on that be?
I would like to see some sort of empirically confirmed data that accounts for that, and if you have it, you should publish it.
Oh, I'm trying, but my empirically proved evidence is that whenever physicists process the Schwarzschild metric, particles stay above the event horizon, don't they?
I don't know what you mean by process it, but the general idea is that if you're an outside observer, you will never see an object fall in. Or from the observer's perspective itself, you will certainly see them fall in. There is an issue, by the way, with white holes, namely that white holes are at a quantum level, they're fundamentally unstable. There are some papers on this that you could probably look into.
I do believe that they would be unstable. But
right, and so the issue is that if white holes are going to exist with stellar masses, then, or rather, we have good reason to think that white holes with stellar masses can't exist, and any white holes that do exist would be microscopic in mass and would only last a fraction of a second.
Well, let's just resume the question. Particles above the event horizon in the Schwarzschild metric, forget observers, the metric. Those particles stay above the event horizon in the metric, correct?
No. They fall in.
They cross it because that's what I've researched and it said.
Yeah, they fall in.
The article said that when the event horizon forms, infalling particles don't reach the event horizon in the metric.
The metric is, I don't know, you keep saying in the metric. In the space-time metric, corresponding to the Schwarzschild metric, particles absolutely do cross the event horizon.
Well, I just scoffed. I don't know what to say. I was told opposite, now I'm hearing two different stories. I don't know which one is true.
Okay, all you have to do is check whether or not time like geodesics can cross the event horizon for a Schwarzschild metric, and you'll find that, of course, they can.
Well, it's very difficult for time like geodesics to cross the event horizon when
No,
the
it's not.
time
They just
coordinate
go in.
vanishes from the metric, does it not?
You don't need a time coordinate in order for time like geodesics to cross the event horizon.
I don't need a time coordinate for time like geodesics.
No, these are coordinate independent things.
All right.
Also, the time coordinate doesn't really vanish, I guess, unless you're in some specific
Oh, it
coordinate
does
system
vanish.
where
I've seen it even in the Kruskal-Zekeres coordinates.
No, I mean the time coordinate doesn't vanish. What you're referring to is the metric becomes singular. In certain coordinate systems, the metric becomes singular, but the time coordinate doesn't necessarily vanish. You can just shift the time coordinate however much you want.
I can remove that singularity because it's just a coordinate singularity. I've seen it done in the Einstein-Rosen.
Right.
But I actually apply the Kruskal-Zekeres coordinates, and there is no time coordinate. I know, I looked at it. There's no time coordinate at the event horizon in the Kruskal-Zekeres.
Okay, so then I think that you're probably confused.
No, I've seen it. What is the time coordinate at the Kruskal-Zekeres? It's singular, isn't it?
Do you want us to put? Well, hold on. Just because a coordinate becomes singular doesn't mean that there's not a coordinate.
Oh no, I know that too.
Okay, then why are you saying it?
If it was a physical singularity, and the physical singularity exists at the origin, correct?
Yeah. So I mean, like you can like so is your question like what is the value of the time coordinate, and you're saying it's 0, or are you saying that the time coordinate becomes singular at the event horizon? What's the claim here?
I'm actually just quoting Einstein and Rosen when they say at the event horizon, the time coordinate vanishes. And I've seen it in not only the Einstein and Rosen, but also in the Kruskal-Zekeres.
It sounds like you're misquoting them because it's, I mean, or they were just mistaken, right? Because it doesn't really make sense to say that a coordinate vanishes unless you mean that the coordinate value is 0.
No, I mean it vanishes. Then that's
a nonsensical
the particle
statement.
Problem in the general theory of relativity.
Then it's a nonsensical statement, and Einstein was wrong.
Bold statement.
I mean,
but anyway, I don't need to even go to Einstein. Like I said, if I go to the event horizon in the Kruskal-Zekeres, the time coordinate actually does vanish. It's not there.
What do you think it means to say that a time coordinate vanishes?
That there's no time at the event horizon. The time coordinate has vanished.
Do you mean
that's why particles don't cross?
So if you mean in some coordinate system, there isn't a well-defined time coordinate. The metric is not dependent on a coordinate system.
It is another coordinate system, but all coordinate
the metric isn't a coordinate system.
When we're dealing with the Schwarzschild metric, all coordinate
just as an example,
emerge from the metric.
Just as an example, you can just go to whatever coordinate system is used in the Penrose conformal compactification for the Schwarzschild metric, and you'll see that there's a well-defined time-like coordinate there. So, like, it's just this is a coordinate issue.
And then I go to the Kruskal-Zekeres, and it disappears. It vanishes.
Well, no, it's just not well defined there. That's because
not well defined as in vanished.
No, it just means that the coordinate chart. It just means that the coordinate chart doesn't cross the event horizon.
Oh, okay. So the coordinate chart doesn't cross the event horizon, and that coordinate chart.
There's a coordinate chart
where
inside
the
and a coordinate.
Exist.
No, the coordinate chart is not a physical thing.
It is a description of the time vanishment at the event horizon.
No, it's
and
not.
My position is that this is what's causing a white hole, and my position is also that white holes are sustained in a process called asymptotic darkness.
Cool, your position is mistaken. Particles can fall into black holes, no problem. There are time-like geodesics that can cross the event horizon. They become, and they stay time-like. In fact, you can see this directly from Penrose's conformal compactification diagram of the Schwarzschild black hole.
Now, if I transform to the Kruskal-Zecchinus and I look below the event horizon, which surface does the particle move upon? Because there are two surfaces below the event horizon in Kruskal-Zecchinus, aren't there?
Yeah, you'd have to just go look at where the geodesic is going.
So there are two surfaces. So you're telling me one particle passes the event horizon.
What two surfaces are you talking about?
Actually, two surfaces.
Look, there's a really good diagram that might help you here. So look at this diagram. See this diagram here? I don't know if you can see it. I'm sure you've seen this. So have you seen this diagram before?
I've based my theory on it. Yeah.
Okay. Yeah. So see that black line? That's the world line of a particle passing the event horizon.
And it crosses. Does that not cross an asymptote? Does that not cross a coordinate asymptote?
Yeah, it does.
Those particles, that time is going to infinity.
Yeah,
and it reaches a singularity.
Time. Right, that's a coordinate time. It's not physical.
I submit to you that all world lines on that path must be hyperbolic because the coordinates are hyperbolic.
Coordinate singularities are not real singularities. No, not another thing.
No, they're not. They're just coordinate singularities.
Right, and so if the coordinate diverges, that's irrelevant.
The particle to above the event horizon.
No, they don't.
And furthermore, when I was talking about those two surfaces,
he's very combative for wanting to get some questions answered. From Clarity Opaque with the $20. Thank you so much, Clarity. I very generous. With the Roman Space Telescope launching later this month, I feel like it's never been a better time to get into astronomy. I'm curious, should I pursue software engineering plus astronomy to scrape its data or go full astronomy? That's up to you. The thing is pursuing astronomy will mean 10 years or something like that of schooling. And by then, the Roman will be old news. I mean, it won't be old news. It'll still be doing great science, but it'll be old news. So it's, if you wanted to be working on the Roman Space Telescope, to like do that kind of thing, you should have been working on it 5 years ago. So then you could be ready to start, so you're ready so you can start analyzing the data right from the get-go. Let me read some more questions. I suppose let's start at the very beginning, prior to the Big Bang. I know that doesn't make sense, but humor me. If all there was quantum foam prior to the Big Bang and it's just virtual particle excitations or probabilities, then how can you hold infinite possibility at a point of t equals 0 and d equals 0? I don't hold that quantum fluctuations are related to the origins of the universe. That's not my view. Isn't that a paradox to hold infinite possibility without a mechanism to express it? I don't even know what this means. I don't know what the d refers to when you say d equals 0. Yeah, it's not quite clear what this means. That's why Guess likes white holes. Unstable and doesn't last long. William Matz, thank you for becoming a level 1 member. Very appreciated. Is he trying to prove Blitz wrong or something? He's trying to prove all of physics wrong. Yeah, it does fall in. Yeah, absolutely it falls in. You're wrong, Einstein. Even if the time coordinate equals 0, so what he's saying is that the time coordinate in Kruskal-Zecchinus, which is or how it's pronounced, by the way, yeah, Zecchinus coordinates. Even though the time coordinate does diverge at the event horizon, that doesn't mean that particles can't cross that. You can define coordinates so that they diverge in any coordinate system, or so that they diverge anywhere. You can just define coordinates that do that. You're allowed to. It's just not physically meaningful. I'm just making sure I didn't miss any questions. No shot astronomy takes 10 years to get into. I mean, like, 4 years of undergrad, 2 years of master's, 4 years of PhD? About right. If Caller can read Ask a Physicist and think he can debate a physicist, what else is he wrong about, right? E equals distance. Oh, yeah. I don't think that the universe had ever had zero size. Isn't that science proving theories to be wrong? It is. Yeah, he's just mistaken about this one. Since you don't agree, could you go over what do you believe about the universe prior to the Big Bang's initiation? I just don't think that they're... Like, I don't know, but I don't think that it was ever zero size. I think that there's some sort of quantum correction that would have, like Einstein-Cartan kind of stuff that would have conflicted with that. Does Blitz read chat? Yes, I do. That's exactly what we're doing here. Is there any physical phenomenon that violates a law of thermodynamics? I mean, sure, like the first law of thermodynamics just doesn't hold in an expanding universe. Answer gotten. Answer gotten indeed. All right, let's bring up another guest. David was going to come up, but David is now back. David, how's it going? Gotta answer your question. David. 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 David.
God darn it.
God darn it, David.
No.
David, I can hear you.
Hello. I'm so sorry about that. And
You're
I'm
fine.
sorry about before. My shrink called me to make an appointment.
Sure, I get
first,
that.
Let me thank you for talking to me. And
of course.
also want to apologize for my lack of academic etiquette. You
Fine.
physicists are literally my heroes. Like, it doesn't matter that you're on YouTube. I look up to you guys.
I appreciate that. But what questions you got for me?
This might take a minute. Is that okay? I have a real problem.
If it's a problem that a physicist can help you with, maybe.
Yes. I just wanted to tell you it might take a second. So
Sure.
Ever since I was a boy, I've been working on this framework like independently of physics, and a lot of the things are parallel. So when I was like 14, I was looking at the moon, and I realized that you can't really have it in orbit without something there. You know what I mean? So I realized spooky action. And I started from the foundation of my framework was that like superfluid vacuum theory. Sorry, I'm really nervous, man.
You don't have to be nervous.
So if you just assume that space is a fluid, I'll start with the Big Bang.
So David, I should warn you. I have a policy of not doing theory review. Right.
Okay. Well, I don't know string very well, and I'm starting to see like the Mobius strips folding up into like the cosmic donut that I thought was a joke, and I'm seeing it fold up into chromosomes in my head, and I'm like seeing giant eggs in the sky. You know, Gedanken experimente.
But so this sounds like look, if you're seeing things that aren't supposed to be there, this seems like the kind of thing that a physicist can't help you with.
Well, no, it's not like that. It's like my framework, I always knew it wasn't one-to-one, and now it feels so one-to-one. I can't tell if like what's real, and it's really messing with my head.
This doesn't seem like a question, like an issue that like a physicist can help you with.
Well, can I just tell you about the Big Bang, and then that'll be it.
Sure, but again, I'm not going to do theory review, but sure, you can tell me.
Okay, so if fluid space condenses into a macroscopic singularity, I didn't believe the black holes sucked in space faster than light for the longest time, which is contradictory because I figured it reaches relativistic speeds and becomes non-Newtonian fluid, which causes things like gamma bursts and pulsar beams. Anyway, it sucks in space at light speed until no more space can fit inside the singularity, and then space slams into it faster than light. And because the particles are so close together, the energy is transferred almost instantly, and then it blows out the other side, and you get the Big Bang. And then the little tiny particles inside the substrate, they they're in the true vacuum, so they lose all their negative energy and they balloon up into protons. And the cosmic microwave background is just boiling space.
So, David, how much physics background do you have?
I mean, I picked up bits and pieces, and I'm studying. I've been thinking about nothing else since August 6th, all day, every day, and I love every minute of it, honestly.
So look, I mean, like there's a lot there's a lot of physics to learn. I mean, like, you know, if this is a good idea, and again, I don't do theory review, so I'm not going to tell you whether it's a good idea or not. But if this is a good idea, then it can wait. Good ideas, it's not going to go anywhere. So what you could do is you could just start taking, like, you know, community college physics courses, or you could start, you know, doing self-teaching, like starting from the bottom, like actually starting from classical mechanics. You could do that, and you know, in a few years, when you've you know gotten a stronger background, you could then come back and reevaluate your ideas and see if they make sense.
Okay. One more thing. The last guy, I think maybe what he was trying to get at, I don't know, is that when a particle like the Hawking radiation type particle, when it's a whole particle, it reaches the event horizon, and the shear force literally rips it in half. So half of the particle goes down.
No, he was just thinking that nothing can get past the event horizon, and he was just mistaken about that.
Oh, because time stops, but that's not possible because
time doesn't really stop. It's just that it like appears to stop from an outside observer's perspective, but it doesn't actually stop for the person following in. So he was just mistaken, you know, and he was very aggressive about it too. But look, yeah. So look, I can't tell you whether your theory is good or not, but what I can tell you is that you will be able to know whether your theory is good or not if you give it. If you put down the theory for a minute. It'll, you know, write it down in a detailed way. Write it down in a detailed way. And then go spend a few years learning actual physics from physics textbooks. Don't skip out on doing exercises. Don't jump right to relativity. Don't jump right to quantum mechanics. Learn the actual fundamentals, and then you'll be able to evaluate whether your idea is a good one.
Okay, thank you. I appreciate it. Like, so that I keep going in parallel with like the highest levels. Like I'm a top-down learner from like I've been that way since I was a child.
That is the wrong way to learn physics. You will not actually learn physics if you try to start with like the biggest, coolest ideas like quantum mechanics and relativity. You will not learn physics that way. You have to force yourself to start from the bottom and work up.
Right. I like, you know, I'm not Faraday, but I feel like I have things in common with him. But you're right. I have been studying. I learned how to calculate Schwarzschild radius yesterday. And that to me is like easier than academic etiquette. It's like an alien language to me.
I mean, yeah. So like, the thing is learning how to figure out or learning how to calculate what the Schwarzschild radius is very, very different from understanding at like a ground level why it has that value, and like actually being able to derive that value. And so like if you can't do that, you're going to have a very hard time talking about black holes at all.
Right. I believe it's a combination of the old 80s rupture black holes with superfluid and river.
Right, but evaluating whether that idea makes sense will be impossible until you actually know what the standard theory of black holes are.
Gotcha.
So good luck.
Thank you.
It's a long journey ahead of you, but it's not impossible.
Yeah, I'm doing it. Even if I have to do it.
Oh, I cut him off too early. My bad. Sorry. Read some more questions. The models that taught us in school said all of space-time itself was closer together in the past, which is how they came up with the Big Bang in the first place. Where do you separate yourself from this? So it is true that the universe was smaller in the past. The observable universe was much smaller in the past, but that doesn't mean it had zero size. And we don't really have any evidence that it ever had zero size. This was an inference that was made. This was like standard lore back in like the 80s, but it hasn't been standard lore since then. What sci-fi has the most sound science? Probably anything by Andy Weir. He's really good. How long did it take you to get your PhD in physics? So I finished my bachelor's in 4 years, and then I did a straight to PhD program, which starts with like 2 years of a master's and then 5 years of a PhD. So I finished when I was 29 or something, or I think I was about to turn 29. Yeah, I was about to turn 29. Just looking for questions, sorry. Oh. So there is another question. What is the correction? Oh, the correction is just that the Big Bang doesn't say anything about that, right? The Big Bang does not say, like, our best theories of particle physics just aren't able to tell us anything about whether the universe had zero size or not. You said it was law. No, it wasn't law. That was lore. It was like the standard lore. As in, like, that was just like the story that like we kind of all understood to be true, and then we realized that it wasn't. Because, you know, we started to understand better cosmology and, you know, other explanations and things like this that, you know, couldn't be excluded, and so on and so forth. If David, is the cosmic microwave background a black body? Yes, it is. It's the arguably the most perfect black body that's ever existed. It just says it goes back and back, and we don't have any info past the CMB. We do have info past the CMB. Our theories can take us past the CMB, up to about like a second or so after the Big Bang, and then before that, our theories kind of start to break down. Maybe a microsecond, maybe a nanosecond, whatever. But like in some period of time after supposedly t equals 0 is when our theories start to break down. Now, everybody has been so wonderful. However, it is almost noon. We only have 3 minutes till noon, and I have to make myself lunch and make myself some coffee. I do have a headache because I haven't had coffee yet. So I'm going to end the live stream here. Thank you guys so much for watching and for contributing and for becoming a member. Remember, if you want to participate in the members only question and answers that I do twice a week, the thing to do is become a $5 a month member or subscriber or super chatter or super fan or whatever it is. That gets you access to that. It gets you access to emojis. It gets you access to my debate notes, and it gets you access to a private Discord channel. So consider it. You don't have to, but you know, you will get your questions answered this way if that is what you are interested in doing. So thank you guys so much for being here, and I will see you guys tomorrow.